Hello and welcome to Talk of Today, where we explore developments in science, technology, and society, and what they could mean for the future. This episode is a bit of a wild one. It is a 3-hour discussion bringing together a unifying principle for life, the free energy principle, with several pernicious problems that have plagued us for years, like consciousness, free will, intelligence, and what the hell is going on when we take psychedelic substances. Leading us on an awe-inspiring tour of these interconnected, mind-bending topics is the scientist Dr. Adam Safron. Adam has recently finished a postdoc at the Kinsey Institute at Indiana University and has moved on to the Johns Hopkins Center for Psychedelics and Consciousness Research. His work brings together neuroscience, psychology, and philosophy from a complex systems perspective, and is truly fascinating. His ultimate aim is providing a multi-level account of the factors that help people to be adaptive, creative, and free in all aspects of their lives. One of his more recent projects has been developing a theory of consciousness, integrated world modeling theory, which in the context of the free energy principle and integrated information theory proposes that conscious experiences are what it is like to model an embodied self and world with coherent organization by space, time, and cause. In my conversation with Adam, we cover the free energy principle, the Big Five personality trait model and its recent cybernetification, intelligence and why the artificial intelligence of the future might have to be embodied in order to reach its purported potential. Adam then takes us through his theory of consciousness, integrated world modeling theory, which leads us to explorations of free will and, of course, psychedelics in the brain. At the very end of the conversation, Adam answers some questions that were asked of him by people on Twitter. So if you're looking for those answers, skip to about the last 10 minutes of the conversation. The more of Adam's work I discover, the more interested in it and his take on the world I become. While we spoke for just over 3 hours, we still didn't cover everything we wanted to discuss. So we have a follow-up episode planned for the near future, where a big part of the discussion will be focused on Jordan Peterson's magnum opus, Maps of Meaning, and how the ideas in it seem to be completely consistent with the free energy principle. As an amateur philosopher who doesn't really know too much, I'm going to go out on a limb here and say one day it may be considered one of the greatest works of moral philosophy to come out of the last century. But that is a discussion for another time. All right, before we get into it, if you'd like to follow up on some of the links or things that we discussed in this episode, they can be found on the show notes, which will be linked below, as will links to Adam's Twitter profile, which I highly recommend checking out. And without further ado, please enjoy my conversation with Dr. Adam Safron. Adam, it's great to have you here. This has been a long time coming. So if we could just begin by, if you could just give me a bit of an intellectual tour, like how did you get interested in neuroscience, and did it start from a young age? How have you come to do what you do?
Well, I guess probably started with a couple factors. One was a existential crisis about free will in high school. That went on for a couple years and was pretty bad. And generally interested in the brain. My father was a temporal lobe epileptic, and so that got me asking certain questions. And yeah, those might have been the two things that set me on the path of trying to figure out what the heck's going on with minds.
Yeah, and so you're currently doing a postdoc. I've got my notes here, but I don't need to check them. Where are you working at the moment?
So I just finished one at the Kinsey Institute at Indiana University, and now I'm starting at Johns Hopkins Medical School at their new Center for Psychedelics and Consciousness Research.
Great. Oh, that's very exciting. Well, we'll definitely dive into both topics later on. So I think central to, I guess, more of your work recently has been this relatively new way of doing science, or exploring, not doing science in general, but way of exploring living systems and mind and behavior, the free energy principle. So I think we connected after my conversation with Max Ramstead. So perhaps we don't need to spend 2 hours exploring what the free energy principle is, though I will ask clarifying questions because I don't think I completely get it yet. Though I feel like this is
Welcome to
it's a
the club.
feeling that's, yeah, I feel like I'm not alone in that, but I like the formal, like the mathematical background to really be able to get it, I think. But I think I've got a handle on it. So if we could, if you don't mind, just talking to me a bit about what the free energy principle is and why it's causing such waves uh, in, I guess, philosophy, but also in neuroscience and other fields, I'm sure.
Hmm. So I'm not sure what I'm about to say is canon, but someone can correct me and yell at me if I get it wrong. Uh, as I understand it, the free energy principle is a general systems theory and a means of modeling complex adaptive systems. And it begins from, there's a couple different ways you can derive it, but one is um, from the observation that really starting in a way from Schrodinger's question, like how is it that there are things that are persisting with complexity in a world governed by the second law? So somehow through in a world where you would expect the most probable outcome to be for things to increasingly accrue cybernetic entropy or disorder internally, um, you should expect the most probable outcome for them to get just all mixed up by the meat grinder of existence. So why don't you see this? So they have to be doing something clever. And so this idea would be from the good regulator theorem, maybe the law of requisite variety from cybernetics. Any in order, the idea would be that complex adaptive systems, in doing this trick of existing, continuing to exist, they're somehow entailing a model of what they are and what they must do by which they are governed. And so the free energy principle, somewhat counterintuitively to people, would argue that persisting systems in their very existence, it's not just that they have a regulating model, some systems do have models that govern them, but that the system itself is a model, that the dynamics of the system have a certain can be understood as engaging in a kind of generative modeling, generating the system preserving states through their internal modifications and their interactions with the environment. And um, that, and so then the free energy comes in is that in these modeling efforts, these active inferential modeling efforts where systems are minimizing, so the idea would be that systems are minimizing their error with respect to these models, which have these implicit predictions of what must be done to exist, and that they're adjusting based on prediction error. And so in minimizing prediction error, there tends to be, I guess, two different ways you could do it. One would be you update your model, you change yourself, and the other would be you change your relationship to the world and change your, so you either make your predictions match your observations or you make your observations match your predictions. And so the free energy idea would be that these modeling efforts, how good you are at doing it, you would um, characterize them or quantify them by this objective function or a cost function that's saying, okay, you want to have good fit, you want to have low prediction error, you don't want to be surprised too often. But in these modeling efforts, you want to obey Occam's razor. You want to minimize the complexity of your modeling efforts, minimize the extent to which you are updating and moving your expectations in the face of data. And so you want to prevent overfitting, prevent getting too complicated, obey the law of parsimony, but you also want to fit the data. And so the free energy comes in as a means of quantifying the goodness of a generative model, where the free energy, uh, I believe maybe it would be Hinton and Day in 1995 with respect to Helmholtz machines, a precursor to autoencoders, That's where that idea first got introduced. And so that, I guess, would be free energy principle in a nutshell. You could think of it as like Bayesian autopoiesis, or
Okay.
like,
Wait, so can we
yeah,
unpack that? Because I don't think, I mean, these are quite niche things. This is more of a general podcast. So what is Bayesianism, and then what is autopoiesis?
so autopoiesis, I guess, would be Maturana and Varela, two Chilean complex systems theorists and scientists, uh, taking on in a way like Schrodinger's question, like what is life, and what the way they characterize living systems as engaging in self-making or autopoiesis, where they, through their action, they specify a given extent of the system, a topology of what the system is, and um, they continually reconstitute themselves through their action. And so that would be autopoiesis. And so then the Bayesian version would be um, recasting this idea in terms of constituting a type of probabilistic inference. I guess coming to these free energy ideas. So it's uh, and where Bayes is just a framework for understanding probability, where you bring knowledge together, weigh it by its respective certainty, and update your knowledge, and then use your updated knowledge to contextualize new observations, which you then update your knowledge further, repeat, repeat, repeat. So it's really iterative science,
Hmm.
and so the autopoiesis. So I guess I would call it Bayesian autopoiesis. I don't know if I would want to call it that, but you could call it that. As if you're understanding these systems as generative models, where what they're generating through their action is model. They're Jacob Howie calls it self-evidencing, that the system is, through minimizing its prediction error, is can also be thought of as accumulating model evidence for itself. It's making it more likely that it can be said that that system exists in that particular kind of way. And so uh, the the Bayes would come in and treating these modeling efforts, treating these probabilities um, uh, formally as a kind of inference, as a kind of learning.
Hmm. Okay, so I just want to kind of give you my take, just so that if there are any inconsistencies or errors, you can correct them, so that this conversation going forward is better informed. Updating my model. Um, so the way I see it, and from what I've read, is all organisms exist in a world, and that world is far more dynamic and random than the internal world. And to persist across time, all organisms either are or develop a model of the external world and their place in it, so their internal um, state, and they try to minimize the error between what the model says the world is going to be like, the internal and the external world, and then what it actually is like. And I guess some aspects where I get a little bit confused is there's this information theoretic notion of surprise, right? So if we're a model, oh no, sorry, if I'm a living organism, I can only exist in a certain number of states to survive. Like the state space of survivability is incredibly small compared to like the the space of all the arrangements of atoms that my body could be in, and there's only a very limited number of those that can um, survive and continue to survive across time. So that's where my body temperature is at a certain temperature, my pH is at a certain pH. There are all these things that kind of need to work. So what the body does is say that there are these states, and deviations from those states are surprising. Um, Surprising in like the information theoretic sense. So we've got an internal model of what we should be like, but we also model the external world because the external world can bring about surprising changes to the organism's body, right? And so I guess the point of clarification that I might be searching for is the complex systems that are, well, if they're engaging in this free energy minimization, they are trying to minimize the surprises, like they're trying to minimize the number of states that they reach internally, so minimizing surprise there. But they're also trying to minimize just how surprising the events in the external world are as well, right? Because those events can translate into death or bodily degradation or something. So there's two kind of surprisal minimization events or activities going on. It's minimizing surprise of internal states and minimizing surprise of what the hell's going on out in the individual world, in the external world. And organisms kind of engage in this. They kind of sample the environment. This is like where active inference comes in. They act in the world. They take in sensory data, and then they update their models to try to ensure that their model is more accurate. And the reason why, it's impossible to have a perfectly accurate model because it's just impossible. It's like the world is incredibly complex and there's too much going on, and we can't store all that data. We don't have the computational capacity to compute all that sort of stuff. So we need to our models need to be more simple, like good enough, or as simple as possible, but no simpler, right? Or as something like that.
I think exactly like that.
Okay, so is that a good kind of characterization of it from your perspective?
I mean, I think it's great. I think that's beautifully expressed. I mean,
I'm trying to write something about the free energy principle now because in one of I'm doing undergrad honors, and I'm trying to integrate this into something, and I'm just like, oh my god, how I don't even know if I quite get it. So I'm trying to
I,
write about it, and it's
I think you do. I think you really captured much of it beautifully. I guess the one place where I might potentially a Fristonian might um, quibble would be in like with respect to active inference, um, they would want to emphasize that the action itself is understood as a kind of inference, and that you so it's in addition to like actively sampling the environment to refine your models, um, which would relate to things like from like machine learning, like artificial curiosity. But in addition to this sort of active engagement to make your models better, um, the action in terms of generating, making your models fit better by changing the world as itself constituting an inference. I think that's completely consistent with what you just said, that they might want to emphasize that point.
so the action itself is an inference because I think from reading from what I've read, we are just constantly engaging in predictions, and because like trying to take in all sense data and then interpreting it and then putting it back together is kind of just really really hard. So what we do is we just make predictions about the world is going to look like, and anomalous events we recognize and assimilate. But everything else, like everything that I'm seeing, is actually a bit of a prediction. But if a dinosaur was to poke its head through your window, my body would be like, oh, that was surprising, and then I would hone in on that anomalous event. There's no dinosaur there, by the way. Don't need. I know you didn't look over your shoulder, but
The yeah, I think that's exactly right. I mean, the one issue that I guess free energy theorists might want to emphasize is um, I think you can engage in different ways with this framework where um, within so like for instance I sometimes think of it as like this onion of like increasingly like specific claims. And so like at the broadest shell you would have like the free energy principle as this general systems theory and almost a kind of metaphysics. By almost I mean a kind of metaphysics. You then go in a little bit more, and then you would start to get like these process theories associated with it. So how is it that what must you do to minimize your free energy? And so then I think it was around, was it 2017, Carl introduced active inference like formally as a process theory of a normative model of what an agent must do to minimize free energy. And then you can have all sorts of additional claims that you may or may not want to endorse. So for instance, so then within the Bayesian brain, the idea is you might think of perception as being a kind of Bayesian inference, and maybe under some circumstances achieving a kind of like optimality, not necessarily in terms of being a faithful depiction of the world, but in terms of um, you know, basically keeping track of the different probabilities, weighing them by their relative precisions, your relative confidence in each of them, and if you do this and you keep doing this, this should be the best you can do. You take in all information and you weigh it by your confidence, given that your confidence, given that you can keep updating and make your confidence ever better, well calibrated. And then there's other ideas like mechanistic implementational theories like predictive processing or predictive coding, where you might think of cortex or nervous systems or all biotic systems as as minimizing prediction error through a particular type of hierarchical message passing and updating. In some of the ways you were describing it, I think it would be like the most. I think it gets at a lot of the power of this like complex framework, and it um, so some would say that it's too Helmholtzian, that it's still like thinking of the system as something that's having a model, and that this model is like a thing separate from the system, and that you're taking care of this model. Um,
Hmm.
for the hardcore free energy theorists, the system is the model itself, and so it's like there's no difference. But I think, and this I guess comes at like some of these debates that are going on within activism, and in debates like within free energy circles, of I think you can have both. I think you can both say that the system as a whole is a type of modeling process, but that there are subsystems which are more like the kinds of models you would think of in cybernetics as a controller and a governor. And in my personal thinking, I ascribe to this. I'm not so there's sometimes a debate between people who are more cognitivists, this view from cognitive science, which would emphasize things like representations and explicit models and knowledge structures. Um, but then you would have like the inactivist schools, which would uh, not necessarily talk about representation or models, but would more think of the coupling of dynamic systems as uh, as being the reality, and that these things like representations might not have any meaningful existence. They might be like a way of describing the attractor structure from without, but that we have to be careful not to to reify these things, to actually say, wait, there are representations, that there are models of the world that are separate from the engagement, from the enactment. Uh, I personally think they're both. I think especially when you get to systems as complex as us, really big hierarchical or hierarchical systems, that you can get basically inner loop, or you can get basically subsystems that are not immediately engaging with the environment, and that these systems, these internal systems, would be more like uh, models of the kind that people would recognize from cybernetics or control theory. That these would be, or cognitive, or good old fashioned cognitive science. That you can have both this inactive, embodied engagement with the world, where some things to talk of representation is actually a very coarse grained way of viewing things. That it's actually just a dynamic, intelligent, adaptive coupling. Um, but that you can also have on top of that explicit modeling. And I personally think we have both. I don't know if that
Okay.
makes sense.
So yeah, I'll just see if I can see if I'm understanding this. So the inactivists are like the actual system itself is the model. It might seem like there is a representational model that is operating within the system, but that's not the case. It's actually just these little subsystems that are coupled together that embody, or maybe perhaps embody is the wrong term, but enact the model, that they are the model, whereas, which I think, did you say the cognitivists or the others are like, yes, but there's, well, maybe, but perhaps there is inside these individual systems, even they may be coupled, but within those, there may be representational models that are informing or perhaps separate to the bigger one that they are contributing to.
Yeah, that's perfect. That's really well said. Like I think that would express like within uh, the free energy circles, you see that diversity of thought. Some people lean
Yeah.
more like radical and activist. They're like, oh, not going to talk about representations or models as much. Like this is just like a way of talking. But like let's not. And then there's other people who say no. There's like Jacob Hauke, Alex Kiefer, I think. But it would be like, no. Let's look at things that are more like we talk about in cognitive science of and control theory. You have models that you are curating and caring
Mm.
for that are governing you, separate from the entirety of you.
Yeah. Yeah. It's kind of that vibes with me more just from like a phenomenological.
Contained within.
Sorry. Yeah, yeah. From a phenomenological, that word sometimes gets me, perspective, because I feel like, in my consciousness, I have models of the way things work. And if they are appearing in, my awareness, uh, my consciousness or some degree of it, then that could be considered some form of model that's separate to the underlying stuff, at least from my perspective. I could just come up with a toy model of anything. And perhaps that model, perhaps what I'm getting wrong there is there's two different types of descriptions of model. They're like maybe two definitions that are kind of going past each other, but not quite connecting. But like right now in this conversation, I'm trying to model what you're saying, but that's not representation of everything, or that's not being like that. That's separate from that. The model that I'm trying to create to interpret and understand this conversation is separate to a lot of the other models that are going on in my body.
Depends on the time scale. I mean, eventually they all get mixed up together. But
Yeah.
in like the immediate unfolding, there's a lot I'm not conscious of, and there does seem to be this like separate factorization where it's there is some degree of um, independence of different modeling efforts, and there's some things which are just not available to me, even if I wanted to have access to them. Even though there might be a kind of intelligence and an implicit modeling going on, maybe even a modeling that's involving my brain as part of it. Just because that's there doesn't mean that that is represented in a way where I can access it or re-represented in any kind of um, way that would be recognizable or would be meaningfully impactful for the moment to moment changes in my experience and my phenomenology.
Mm. So it might not be consciously apprehendable. It might be like lower level going on underneath, and it doesn't poke through to the surface, so that we can be like, aha.
And you could think of that like so it depends like how radical you want to go along which dimensions within activism. So some people would argue that, for instance, there are people who would actually argue they want to consider consciousness to be actually something that extends not just within the organism, but actually into the world, into the environment, and that it's actually the whole process that isn't even it's not even not only not brain bound, it's not even body bound. It's um, like Chalmers and Andy Clark with extended mind. People might talk about like an extended consciousness. Um, and there's I personally tend to go with I guess radically inactive with respect to treating mind as extended, where I consider mind to be modeling, mind to be intelligence, but consciousness itself, I would actually push way back, not even to the whole nervous system, but actually to um, uh, in more inner processes, inner systems that are more shielded and that are hierarchically higher and are capable of giving you an estimate of the overall system and its engagement. And so but there would be a particular scope over which that information would be exchanged, over which those modeling efforts would happen on what there's a particular spatial and temporal scope, and that some things might be in and some things might be out on the timescales at which your experience is generated.
Mm. That kind of maps onto my understanding of, well, like how I think about these things as well. I mean, there's no reason why, the feeling of my sock against my toe kind of needs to, you know, fit into my, like, be integrated into my conscious awareness at all times, or all these sorts of things. It kind of makes sense from just an efficiency standpoint to just kind of discard a lot of this information that may not be super relevant to conscious experience. But right now, if I'm thinking about it, then it obviously becomes relevant because I am now talking about it. And then I'm like, oh, there we go, nice fluffy socks. Um, so this, I want to talk about intelligence for a little bit, because I don't know, I'm not very familiar with the literature at all, but I feel like this could be a big, um, one way of developing some generalized definition or measurement of intelligence that goes across systems. Um, because, like, what is intelligence? Like, how do we think of it? It's the you just kind of learn things quickly. You can process things faster. You can undergo you can complete complex operations faster than perhaps someone else. You can store more information. Um, I think it could be kind of reframed in these free energy terms, and be a measurement of sorts. Is that kind of, because I don't know what the literature says, so perhaps this has all been said and a lot more. Like, could you give me a give me your take on this?
It's actually really, I think you're right that the free energy principle is actually very relevant to trying to have formal models of intelligence. And I think it's actually interesting that it's not more often framed in that way. Um,
And
but
it takes into account curiosity as well, and creativity, which I think is really interesting, because when you try to measure intelligence, like, you could score 180 on Mensa, you could be a member of Mensa, you could have like a crazy IQ, but you wouldn't, you might not be super creative. So, like, the way I think about it is, and this is why I think creativity and curiosity trumps intelligence, because an intelligent person can learn something very quickly. That they can learn a process. Well, perhaps someone with high IQ. When I say intelligent, I mean, like, perhaps in the more limited, conventional sense in which a lot of us use that term. An intelligent person can learn something quickly, and they can apply it quickly. They can maybe undergo the processes necessary to achieve a goal quickly. But the creative person can say, "Nah, I don't want to do that anymore. I don't want to ride a horse to work. I'm going to create a car, and I'm just going to just trump all these really intelligent people with this form of ingenuity." So even though the creative person may not have the same intellectual horsepower, to put it one way, than the hyper intelligent people, their ability to generate new ideas and new technologies, these um, just ways of manipulating the world better, is just, it beats intelligence in some respects. And I feel like the free energy principle, or this sampling of the environment, developing a model, being curious, um, putting things together, I think kind of brings it together in a better way. I'm not super familiar with intelligence literature either, so
I mean,
who
so like,
knows?
I mean, intelligence like that. I really like what you're saying in that there is something smarter than the ways intelligence is oftentimes understood, and that creativity and active curiosity being part of that. And I guess among different, I mean, usually like, so I guess in psychology, intelligence is understood as a kind of latent factor that's put forward to account for the fact that a lot of these different capacities all seem to hang together. And so if you do a factor analysis and you're seeing, okay, what varies with what, and is there like a clustering of these different capacities? Among all of them, they seem to have this high level factor structure, and so the G factor would be what combines all these different capacities of mental, different kinds of mental prowess. If you're talking in, um, and then within there, what's most important for actually being smart in the ways that are meaningful, you'll have people differ in terms of what they emphasize or uh, what they think is more or less important or how they frame it. So you might have people who are really they think that things like mental simulation and the ability to precisely uh, manipulate and rotate things in your mind, like having like a working memory that's powerful and flexible, that might be the thing. Or you might have like
Yeah.
more knowledge
I've got
based.
aphantasia. I can barely see anything in my brain. Like
You do.
yeah, like if I close my eye, if you ask me to picture something, I can't see it. Like I might get a little flash of it, but I can't hold it there. And it's quite abstract. I can kind of see everything. I can see but not see. It's just like kind of like echolocation, but if it's kind of like if I close. Uh, it's really hard to communicate these, this experience to someone who, because we all have these unique
What is it like,
experiences. But
Sam?
yeah. It's good and bad. um, but yeah, I can't see things, but I have like this. There is like spatial awareness there, and I kind of know how it all fits together. And I might get flashes of like the shape or the color or something, but it's not like an image. Whereas my partner, she can just see things, and her dad was a painter, and he could just close his eyes, or he could just imagine whatever and just paint it perfectly. Whereas what I would if I was to try to do that, I would like have some stick figure with squiggly lines for hair.
Oh, I mean, there's
Yeah.
actually a lot to talk about there, and um,
Well, I have this hypothesis that people with aphantasia, because we can't see things, well, I think on the scale of 1 to 5, I'm like a 2. I'm not like full cognitively blind, for lack of a better term. Um, I think that people like I think this guy called Walter Viet. I don't know if I said his last name properly. He's doing his PhD at the University of Sydney. He did like a little sample, a little Twitter survey or something, and I think people who study maths and philosophy are overrepresented um, as having aphantasia, and I think because if you can't see things as well visually, perhaps you get better abstract acuity. You can engage with abstract ideas better because maybe everything is more of an abstraction to you than someone who's has a very high mental level of visual a high level of visual mental acuity.
could even go in both directions. We're like engaging in abstractions, maybe at certain like sensitive ages, like certain patterns of thought outcompete mental imagery in some ways.
Mm.
Um,
And
they have
that
been
ties
increased.
into some of your work, like the um we'll come to this, but I think in some of your work you've kind of proved that, or you show that sexual God, it's a bit alien for me. What's the word? Sexual
Orientation.
orientation can be kind of like a um, what am I looking for? It's like a path that you walk down. Like the more you
Desire
walk down a certain path, yeah, and the more you traverse that path, deeper the pathway, the deeper the rut, the whatever, however you want to call it, is formed. So is that kind of fits in here?
same similar kinds of looping effects and with respect to development, where like you have the circular causation and which led what at which points can become very hard to disentangle, but where the whole way through
Mm,
we have to consider the processes that feed back on themselves um, at different with a certain historicity, and that
yeah.
this is going to be part of whether we're talking about people's affective tendencies or their cognitive tendencies. Before I
Hmm.
forget, though, with respect to intelligence, I guess a few more things would be in like AI and machine learning. So one formal definition of it uh, would be, I guess, from Marcus Hutter and Shane Legg, and they would describe intelligence as the ability to achieve goals across a wide range of environments. And so that kind of definition, I think, would support what you're saying about it's not just like being good at knowing things, but it's good at knowing how to know things and learn new things and bring things together in different ways for the sake of achieving goals. Um, and if you'll get a different approach. I guess recently, uh, Francois Cholet, who will say that will really emphasize not the achieving goals, but the learning. and the idea, and so this would be more related to curiosity and creativity that could come from that, but um, it would be the ability to learn new things and generalize your knowledge above and beyond what you already have, above and beyond a certain set of core knowledge, your priors. How good are you at learning new things? That'd be another way of approaching it. And it seems like the free energy principle and active inference could be compatible with all of these, depending on where you engage with it. Specifically, once you get to the process theory of active inference, what you're doing is you're not just minimizing free energy of like being in a particular state and just having a good perceptual model, but with active inference, you're trying to achieve goals in the future, and you are planning to achieve these system preserving goals across time. And for the sake of this, you end up um, looking for information. You end up seeking out opportunities for learning. You end up becoming curious. You end up trying out new things, so that your modeling efforts will pay off uh, overall in the long run. Um, I guess if I mean, ultimately, intelligence, it's just a word, like all our words, um, and there's no one meaning. That's like the one, that Plato's philosopher king has written down, and that's the only one. But I guess for me, I like uh, uh, modeling ability given resource constraints, or you can think of it as inference and learning ability given constrained resources. And the better you are at learning, the better you are at inferring. That's how that's how intelligent you are. There's some interesting connections actually between these formal models from artificial intelligence of things that like Shainleg and Hutter came up with the ability to achieve goals. They have this um, uh, embodied in an architecture called AIXI as a formal model of intelligence. And that actually has deep parallels to the free energy principle, and that you're basically, with the AIXI handling, what you're doing is you're specifically trying to achieve goals, but you're doing so in a way where you are using this set of it's based on algorithmic decision information theory, and so your modeling efforts, uh, you are penalizing them based on the uh, length of the description of the program, the abstract program that you would use to describe what you're doing. And so basically, the shorter the program, the more you come out ahead. And so in a way, it's the same setup. Good fitting modeling with Occam's razor in both cases. And so in a way, it really that I'd say that whether we're talking about just modeling the world just to figure out what's going on, or achieving particular goals in the world, um, it seems like there is a convergence across a lot of these different perspectives and a lot of overlap.
Mm.
Yeah.
I remember seeing one of your tweets probably 6 months ago or something, and I think we might have spoken about it briefly, but not in this conversation, but prior to, but how intelligence needs to be embodied. So if we want to build these artificially intelligent systems, perhaps general artificial intelligence, it needs to be embodied in some sense. It can't just be, I guess, it depends what you mean by embodied. But does that strike any bells? Does that remind you of? Did you give a talk at DeepMind or something on something like this?
Um, the DeepMinders at NeurIPS 2018, they had they've had since then, but they had a safety workshop, AI safety workshop,
Hmm.
and the people there were talking about different perspectives on how you can make AI systems safe, whether we're talking about just reinforcement learners in an industry context, or even things like superintelligence. And I was coming in and talking about what we might be able to uh, learn about intelligence and safety with respect to it from the human example. And so um, for biological systems, it seems that the way we're capable of becoming good modelers, or the way we're able to acquire a rich knowledge base from which we can make inferences and learn new things, there's this bootstrapping process. And so, and you can describe this bootstrapping of knowledge process in different terms. So if you're in cognitive science, you might talk about a chaining of analogies. Whether if you're thinking of like George Lakoff, like that would be chaining of analogies from your embodied experience. Um, uh, Deirdre Gettner would say similar things, but be less like emphasizing the embodiment aspect as like the base of knowledge. But you could talk about like new things that you're learning by reference to older things, and you can say this is a chaining of analogies of interpreting the new in terms of the old. But this is really the same thing as Bayesian inference, where basically you combine your prior knowledge with your present observation, you weigh them by your respective confidences, and then you create a posterior or your new knowledge, your new expectation of what it is. And this then serves as a prior for the next round of figuring things out. And but this idea though of thinking of things in terms of so like applying your prior to what's going on, really that is an act of analogy to say that this situation is like the previous situation. And so it's a very similar thing, but expressed rather. I say like analogy is the core of cognition, and Bayesian cognitive science. They're both these bootstrapping stories, and ultimately, I think, saying very similar things, but from different frames. So I guess where the thinking, so where my thinking is coming into this is I'm suggesting that to get enough traction, to get like a toehold in the bootstrapping process, that you can actually really come to robust, flexible, encompassing world models that actually are fit to purpose for figuring out what's going on and getting through the world. Um, the, Biological systems might have needed a certain trick of actually using the constraints and affordances of the body itself as a source of foundational priors, or you would say reliably learnable posteriors. So, like if you take your hand, you're like an infant learning its hand. So you'll actually almost never get a better condition for learning than that because you have multiple data streams non-overlapping in their richness and ambiguity so they can correct for each other and be synergistic, all converging, all varying in real time. You have the
And are you
modality of
referring to fingers? Like in
fingers,
this, but yeah.
just learning your hand as an object, like what is my hand. If you're so people like Liz Spelke would talk about core knowledge, and like and this would you have things like uh, conservation. So you'd have objectness. There are objects in the world. Uh, agentiness, like there are people who do things. Um, Time, space, cause, different like things that are kind of core aspects of basic things that let you build a mind, but you need these. So I would say, like, I guess, in machine learning, inductive biases in there first. You need these priors. And so the claim I make is that the body itself is a really good prior or source of reliably learnable posteriors. That you're going to really be able to learn your body much better than so. If you're just an infant, like staring at the world, and you can't interact with it at all, well, you're dealing with this inverse problem of like things could be small and close or big and far away. You don't know where things begin or end. They're always moving around. Like how do you make sense of it? Where do you begin? And so the claim I make is what gives you purchase is you learn a system that's more fruitfully constrained first, and that's your own body. So you have the converging modalities. You have the modality of action. When I do things, that converges with what I feel. I can resolve my uncertainty by moving it about. I can touch my body to itself, so I have like body-body interaction. It feels like something, so you attend to it. You focus the optimization power on learning this thing. And so across all these different like features, I think it's basically a near ideal learning curriculum that lets you constrain the inference space enough that makes this bootstrapping of intelligence tractable. I can't prove it, but I would go as far as to say that this isn't just what biological systems need to do, but it might be the case that all intelligences that we'll ever be thinking of will need to do something very similar. That like you could throw all the compute in the world at it, even future compute and all the data, and the inference space might still be too under constrained to actually figure out a world model, figure out what's in the
Mm.
world without using this kind of learning curriculum off of starting with this easier kind of training wheel system of the body.
And
I don't know
also
if that.
provides um, something to it's it provides the system, like whatever you want to call it, with something that the data is relevant to, right? You need to like the importance of one thing being in relation to another is critically important to understand what either thing actually is. If you just have all that data and you just like throw a machine learning algorithm at it and be like, figure it out, it might not develop something that we would call intelligence. It might be able to pick out certain patterns, but it won't be able to integrate those into anything that we would consider to be intelligent or even vaguely resembling consciousness.
You use the word relevance. I think that's really key. The other thing about another way of putting it, and the other key thing that I think embodiment provides is it helps you tackle the frame problem, the problem of what will be relevant to the situation. What is the of everything that could go into the mix right now? What is the scope of things that you ought to consider? And if you're always moving from this place of leveraging your prior knowledge and specifically being, I guess, tethered to your embodied engagement with the world, which you can kick free of that, tethering to different degrees. You can imagine different things. You could have different types of experiences, some psychedelic experiences, like embodiment falls away. But that if you're almost always in your modeling efforts and in your conscious modeling efforts, thinking of embodied engagements, that really narrows the scope of what's relevant, narrows what you should attend to, and that
Mm.
makes the problem more tractable.
Yeah,
Um,
and that done over time. Oh, sorry. Continue. I was just going to say that um, we've been doing that for basically since day one in a way, and when I say day one, I mean we're in the process of a lot of evolution, and because of that, rather than seeing like I see objects, right, and objects they seem very obvious to us, but in reality they are far less easy to apprehend. Like just started from scratch, you just can't apprehend it. You don't like. How do you know what's separate from what? How do you know that a tag is actually a part of the bag, or is it separate too? I was holding up a bag for those who are just listening, um, and I think that's what early robotics. That's what they struggled with because there's actually like we just intuitively or just intuitively interpret and see the world as filled with objects that have defined boundaries, and that's not immediately obvious just from taking in sense data. It's obvious to us because we've just evolved that way, and it makes sense for us to ascribe boundaries to certain things and to say one thing is another because obviously it helped us live and survive. But trying to get artificial intelligence systems to do that, it's not an easy task.
we're still struggling with it, and the enduring problems of AI. Like we've made progress in vision, but and the language model is recently very impressive, but they're brittle. They're not. They're still really vulnerable to these adversarial examples. You change something slightly, and they just get it completely wrong. And the reason is they don't actually have a real causal model of the world like we do.
Yeah, I think a great example of this is if you ask, I don't remember which program it was or whatever, but it was basically you ask this artificial intelligence system to generate pictures of dumbbells, and all the dumbbells have hands attached to them.
Yeah.
Yeah, did, did you hear
Oh,
that?
just like they're holding arms, like
Yeah. The dumbbells holding arms. Yeah, yeah, yeah. And I just think that's funny.
the arms are holding
Um,
dumbbells. There's like an arm attached to them. That
yeah,
need not be
yeah,
the case.
yeah.
It's
Um,
I guess so, to loop around the reason I was talking at an AI safety workshop is I was arguing that a lot of these things that people are concerned about um, end up being somewhat moot or sidestepped under this biomimetic regime. So, and so people like Nick Bostrom argue that intelligence and values are completely orthogonal, and that you can have any degree of intelligence paired with any value structure, and that because of this, um, and because values are complicated, um, any intelligence we're likely to build, let's say we build a very powerful optimizer for getting things done in the world, but the values aren't phrased just right. The complexity of our values isn't captured. Well, it'll do things like it'll set whatever is not specified, it'll probably set to zero. And then whatever is specified in the utility function, uh, it might realize in perverse ways. And so,
The most famous example being the paperclip maximizer. Um, yeah, where
yes,
there's this. Yeah, for the unfamiliar, we build this device, and all it's meant to do is build a lot of paper clips. And unfortunately, it's like a super intelligent paperclip builder, and it just destroys the universe in its one and true, in pursuit of its one true goal of just making paper clips.
there are only paper clips. That is the end game for existence. That's how
And the
we
king of all the paper clips will be the Microsoft Clippy,
laughing and
reigning over the universe.
staring into the void with untold menace. Yeah, hanging, high fiving with Cthulhu. Yeah, that's one way we could do it, but I think that doesn't quite apply to systems we're likely to build, and it doesn't apply to us. Um, I guess I would, in that our intelligence and our values, they're intertwined from the beginning in multiple ways, both in terms of the way we engage with the world and figure things out, but also probably I would say the lion's share of our intelligence is the cultural endowment. It's natural language. So values are coming in first, a certain type of organismic value of just this kind of embodied bootstrapping process. You have some value intelligence coupling then. But I think it really comes in with language and that and social learning. Like I am garbling my words, I'm being vague, but you have some sense for what I might mean because you have some idea for what I'm trying to say, and vice versa, because we're fairly similar. We have similar ways of life. We tend to value overall similar things with differences, but there's enough common ground that you can constrain the inference space of what I might mean, and that my hallucination can match your hallucination, and then we can keep moving the meat bits and have them vibrate, and we move them, and we can co-hallucinate in a way that lets us coordinate and and have synergy. Uh, it's not clear that this can be done without knowing about what the world is like from engaging with it and engaging with it in a similar enough way that you can, by analogy, or use your own experience as a prior for who you're communicating with. And so now, without natural language, we didn't encode all of our knowledge in like a predicate calculus of like a formal, like we didn't just put it all in this database with perfect logical expressions. Rather, most of our knowledge is encoded in this messy way, good old fashioned natural language. It's rife with metaphor. And the reason that we can grok the metaphor is because we have this common base domain, and we can of our shared experiences, and also intention. Like a lot of it, it's not in it's the a lot of the meaning is not just in the raw semantics of like the way syntax is structuring things and what's referenced, but there's a pragmatics of the communication. And without the pragmatic code, it's going to be pretty hard too. But how do you have the pragmatic code unless you have a good theory of mind? How are you going to have a good theory of mind with reference to what? And so it really helps if you have the similarity. Now, I mean, I'll grant it's still non-trivial. There's still non-trivial safety issues if we ever got to this point of creating like human mimetic systems, and that like psychopaths exist, and there's like our values and intelligence, they're coupled, but they can go wildly different across us. So there's non-trivial issues there. Just probably not paperclip maximizers. Nothing like
Hmm.
that. That's
Yeah, and this, if you take this free energy perspective, um, from intelligence and values, like intelligence, what do we value? We value survival, like continuity of our bodies and that of our continuity of our bodies and that of our friends and family, perhaps our species, perhaps that of others across time, right? So like, and that is realized through um, the these active inferences, this free energy principle. So they are, and if we characterize that as some form of intelligence, like they are inextricably connected. And I'm thinking like, I think we'll come to this. I want to put a pin in this, and we come to this towards the end of our discussion because I
paperclip.
think it fits. Yeah, we'll put a paperclip in it. Haha. And we'll yeah, and we'll come to this towards the
I'm
end of
sorry. I'm
the.
so sorry.
No, no, no. It was perfect. It was perfect. I'm just embarrassed that I didn't say it.
All right.
I wish I had thought of it. But see, this is the creativity coming out. It's not just about being intelligent, but being able to come up with new awesome things.
Keep the puns coming. You can call me the
Yeah.
Punisher. I'm sorry. So
um,
you're putting a pin in something.
putting a pin on it. Putting a pin on it. Okay, so I
But
think
that's a
I just
perfect example. I'm putting a pin in it. Like you can have like a database of idioms, but there's like a sense of what that means because you're visualizing a particular
mm,
type of thing, and this is now relating to a particular class of experiences, and now you're getting a sense for like pinning down meanings. You're getting a
yeah.
sense of like having a grip on something that later you can reference it. So it's not it's there's a simulation that was run
Mm,
that you were able to unpack. Your generative models are able to unpack it because of a particular kind of experience. I'm going to put a pin in it. You could have a database
yeah.
of idioms, but that's not. We can come up with a new idiom like right now. Like I'm going to put a paperclip
Hmm.
on it. Like we can. Yeah. Actually, I don't think
There's
that might be technically wrong. You can't come up with a new idiom right now, but we could we
yeah,
could
yeah,
start.
yeah.
Yeah.
They need to be like maybe like the definition of an idiom would need to like it needs to exist in the minds of X number of people for it to be considered an idiom. Like that's I. This is why I'm kind of excited about this idea of like we hear lots of talk about like what is knowledge and blah 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 blah. But what's kind of cool by taking this I guess highly physical materialistic perspective is that um, knowledge is embodied. It is like it is it it exists in a substrate of some sort, right? Like you can't just have knowledge that's not connected to material, like to matter at all, right? For us to have knowledge, for us to have something, information that we can interpret, that information needs to be it needs to exist in some sort of material substrate, the material substrate gives rise to the information, and given that information, or can have varying degrees of utility, then those certain arrangements of matter have different ethical values, right? So, like the piece of paper with, I don't know, Einstein's theorem or whatever written on it might be like a hell of a lot more valuable, ethically valuable than paper with just like random letters on it. So there's like ethical value tied to arrangements of matter that are inert, except for our ability to take useful information away from it and then put it to use, put it to work. It's like very it's just, highly pragmatic. It's just like, and we can kind of figure out what works because it's just, like, oh, this is good information because it does good things. I mean, I'm no philosopher of science or anything. So for those listening who are, like, forgive
I,
me for.
I'd say you are, and the yeah, it's pragmatic the whole way through, and there's an interest the whole way through. We're not just modeling for the sake for kicks. We're not just modeling so we can say I got it right. We're
Yeah.
modeling to our models, our knowledge. It's tools in the metaphorical hands of a hungry animal.
Hmm.
It's how we and not just of any hungry animal, but of people with
Yeah.
like trying to. And there's an ethics from from the beginning of like trying to have us be a certain type of being with others, realizing a certain shared way of life. And this is structuring. So our whole knowledge bases they're structured in these ways. This is
Yeah.
yeah
Yeah. And it's cool that, words are these, like, the way I think about words is that there's an infinite number of patterns out there, right? There are so many different ways in which we can interpret the world, but there are some regularities, and we slap a label on them, and we come to agree that this word means that maps onto this set of patterns reasonably well, but not perfectly, because you can't. There's no perfection, right? But it's just like it's good enough for us to use, such that we can coordinate ourselves better in pursuit of maintaining social order and surviving across time. And these words, they evolve across time, because the meanings change. The patterns that give rise to them might be a little bit different. Like justice, for instance. Like, we perhaps justice today means something very different to well, like the material, like the material correlates of justice are probably far different now than they were 10,000 years ago, because we didn't have cars back then, and going on a terrible rampage with your car couldn't have happened. So the material correlates that give rise to that aren't exactly the same, but the information, like the way they are structured together, the way we interpret it, and the effects those patterns give rise to. So it could be, murder with a club 10,000 years ago, and it could be, someone rampaging with a car. Very different circumstances, but the way they kind of come together, there's this shared sense of something unjust happening or something wrong.
How
We have these shared like just ideas, and it's just imperfect but good enough. Good enough is good enough. And this is something that really gets me about like the body as well, right? Like we don't know things, like our cells aren't getting it absolutely perfectly. Like one small like what's that in chaotic systems, or like the initial
sensitive to
conditions can
initial
have
conditions? Yeah.
yeah, but like that's not the case in our bodies. Like it doesn't really matter what happens at the level of one cell. Like I'm still going to be generally fine. Like these things don't really I'm not gonna. I think I might just befuddle my words here, but like the long story short is, the amazing thing is that when it comes to navigating the world, good enough is good enough. You don't need to be perfectly accurate. You just need to be like accurate enough.
Like, yeah, I will meet you, but like it's like words. They're almost like Schelling points, like points of coordination outside of really being able to fully communicate. Like so, like we're all words are wrong. Some words are useful enough or serviceable enough, and it's so if I say like let's meet by the Eiffel Tower, any sort of number of things could be going differently. I can, I get hungry along the way. Um, some, in terms of like amplification, chaotic amplification from initial conditions, all sorts of things can start to diverge. But if we roughly though get the same sense of like Eiffel Tower, and we wind up roughly in the same area of state space, well now we can like share a croissant. You know, it's like, but but everything else not just can but will be different. Everything, and so it's like words just need to be good enough that you get a rough enough alignment so we can keep kicking things back and forth and our hopefully have our grounded hallucinations decently enough grounded that we can get along in the world and that we can achieve goals. But
Yeah,
yeah,
it makes me think of, if we want to train um, systems like artificial intelligence systems that can kind of grok or understand the meanings of words. I mean, I think one of the best examples of how the meaning of a word has changed for me is just the term complexity, right? Like 10 years ago, complexity meant something completely different to me now. But now, because I've just spent the past few years like really interested in complexity science, and now when I hear the term complexity, like my interpretation of it's completely different. And this is the same case for all sorts of words, right? Um, from like meme, like I think meme 20 years ago probably just meant like had like some sort of biological. It was Dawkins. Was it Dawkins who came up with the meme?
yeah,
Yeah,
end of
and
the
now
sentence.
I get, yeah, like sorry, but that's not what memes really are to me. Memes are the things that make me laugh, and I'm just thinking about how will we
The
train these
medium
artificial
evolved
intelligence?
or it
Yeah, yeah,
devolved.
yeah. I think it's a positive evolution. I think it's good. Memes make the world a better place.
They help us understand each other.
Yeah, yeah.
It,
Um,
to come back around to AI, it's just not at all clear to me though, without experiences in the world and a roughly mammalian motivational structure, that you have a snowball's chance, um, in proverbial hell, of actually being able to do what we're describing here. It's you. It's being able to get the right simulation from the right set of configurations, where the right is always wrong and just good enough. But to be able to unpack these ambiguous strings that could map onto like so many different things, and to actually get a reasonable simulation that when I generate my next string of sound, or letters that and we exchange, that as we go back and forth, there will be this consistency, and we'll say, yeah, there's understanding there, and that we can actually coordinate and build and plan. It's, I mean, you'll get some of, like, what's going on with natural language processing. It's incredibly impressive. GPT-3 is amazing. It's just not enough to actually get us the bootstrap of cumulative cultural evolution. That's the secret of our success. The cultural endowment, that's the lion's share of intelligence.
Mm.
And so without that, I don't see how you're getting super intelligence without the linguistic bootstrap. And so, but now if values and ethics of these kinds are baked in from the ground floor, then this now creates path dependencies and mutual. This then makes it such that um, values and intelligence aren't orthogonal. They're deeply intertwined. They're not completely collinear either. They can still diverge wildly. We can understand each other and have radically different values, but it's not paper clips, and it's it's a different game.
So I know we've spent a bit of time on free energy principle. I want to talk about cybernetics and Big Five.
Mm.
Big Five being the Big Five psychological trait uh, model, or the five factor model. Um, that's the most scientifically rigorous personality test or model that we have, at least to my knowledge. Um, so I understand that you've done some work with a guy called Colin DeYoung. Is that right? And he was he involved in the early days of the development of the Big Five, or maybe not the early days, but you know the torch was passed on to him, or something or other. Um, is that the
He's
case?
so yeah, Colin DeYoung. So I mean, the Big Five. It's it was before his time when it was first got going, but he did some I would say major enhancements to it. And
Yeah.
so, starting out from the lexical hypothesis that we talk about things that uh, that matter to us, and some of the things we talk about are meaningful and are uh, good ways of clustering the world, and that you then do clustering over this. You do factor analysis, and then among all the different
So
ways
it's like
people.
abstracting, right? So you like see which ones fit together, and then over time, all these words that we use to describe people, they end up fitting into you know 5 or 7 buckets, depending on how you look at it.
Depending on, yeah, so you can induce different factor structures depending on how you do it, but you would tend to get these big five dimensions of variation. Um,
Yeah.
and
And
so
those who are unfamiliar, the Big Five: openness to experience, conscientiousness, so like how industrious or hardworking, tidy you are. I am on this. I'm in the second percentile of conscientiousness, unfortunately. um, extroversion, neuroticism, so your propensity to experience negative emotion, and agreeableness, so like how you know polite. I don't know if polite's actually one of the dimensions, but how nice you are and how likely you are to go with the flow with other people. Um,
then I think it ends up being more like politeness with um, the six the six factor structure of like the hexaco model,
okay,
which is largely similar to the big five, with some
okay,
interesting differences. But um, and so where Colin came into this is, I'd say, has a few different contributions. Um, in terms of just describing the factor structure of personality, he helped to describe its hierarchical structure, and he specifically would talk about these two meta traits above the big five, of shared variance of these different subcomponents. So above conscientiousness, agreeableness, and the inverse of neuroticism, uh, he called this higher order factor stability. And then above openness and extroversion, the other meta trait he called plasticity. He also, within underneath each of the big five, a more fine grained factor structure, uh, described how there are two, and interestingly, um, for him, for his modeling, only two more fine grained aspects underneath each of the big five trait domains. And so if we're talking about openness, that one would be further factorized out into openness to experience and intellect, conscientiousness, orderliness, or industriousness, agreeableness, politeness, or compassion, or something like that. I
Mm.
forget. Extroversion, um,
Yeah, I haven't been able to
enthusiasm,
remember them either. Oh, yep.
enthusiasm, or assertiveness. And so with agreeableness, openness, conscientiousness,
Neuroticism.
neuroticism, uh, volatility, or withdrawal.
Hmm.
Uh,
And some of those are like negatively correlated with each. Oh, well, no, I was watching a talk the other day, and like some of those factors that you would assume are correlated with one another actually aren't. Um, I think this was in reference to uh, political leanings. So I think there's no correlation between agreeableness, and political um, affiliation or political leaning, but there are correlations between the aspects. So one aspect is correlated with one position, the other one's correlated with the other, and they cancel each other out.
it's I think that's among like Colin's an incredible thinker, and like among his contributions, that's one of the biggest ones I'd say, because like people might oftentimes look for correlations at the level of the big five, and because at the aspect level you might have these different qualitatively different things that can go across purposes to each other. If you average those together, you may not see something meaningful. But then if you
Yeah.
go down and you look at the aspect level, then that's where you would get the the more powerful predictor variables and empirical
Hmm.
correlations. And then the
Should we consider it the Big Ten then? Like, why have the five?
uh,
Perhaps perhaps like I mean I know nothing about this, but if that's where more of the interesting stuff happens, I guess there's no harm in like the abstraction. Like I guess for more like coarse graining purposes, it's fine. Um, but yeah, it's just interesting.
as you move upwards, it seems like you might get increasing degrees of universality across different types of agents or beings and across things like cultures. So if you were um, the more fine grained you go, the more particular it might be, and the more um, this in terms of personality as characterizing the the attracting states of a system. Uh, you there's a cost of generalizability to going too fine grained.
Yeah,
But
I was just gonna so for just to I guess kind of for for this conversation, the Big Five was initially developed um, as a personality test for humans, right? Like for people, but it can be kind of reinterpreted in a way to describe uh, cybernetic systems, and that's the context in which we're going to be speaking about it from now on. Because I could sense that with one of the words that you mentioned, I can't remember, it kind of like had that cybernetic feel to it. I'm like, okay, maybe we should just kind of say it does describe human beings, like our personalities, but the interesting thing is it could be kind of interpreted in this more abstract, uh, you know, universal way to describe the actions of systems.
and that's one another reason to focus on the big five, I'd say, and that's like part of why Colin called it cybernetic big five theory, is he was talking about this basic cybernetic cycle of a system having a goal and then or selecting goals and then looking at outcomes and then looking at the error with respect to the outcome and what you intended, and then iterating and then updating and altering your approach. This basic cycle of any goal-seeking system needs to select its actions, observe did it work, and then correct based on what happened. And so with Cybernetic Big Five there, he would map the Big Five onto these different phases of the cybernetic cycle. So like something like conscientiousness would be like the ability to maintain the goal, a particular set of goals, in the face of potential disruptions, or keeping like their relative prioritization straight. Things like neuroticism would be like your sensitivity to error. Things like extroversion would be how the degree of like the readiness of selecting your actions, and the degree of driving of the goal. Um, Agreeableness, it's not necessarily as universal, but it would be like in a multi-agent context, like what type of goals do you pursue? Um, and openness, that one would be more like, I guess, I forget how he had that one within the cybernetics cycle. I think it was something like, um, so he'll tend to describe them both at the big five level and at the aspect level. Um, but that would be more related to what we were describing earlier in terms of creativity and curiosity.
Mm. So what does cybernetic mean? Because, if I was to just hear cybernetic outside of, I know a little bit about it, but I would just think like, all right, Terminator, cyborgs, um, you know, human computer integration. I'd think of all this sci-fi stuff. Um, and
Yes.
perhaps some of you listening to this right now are on the same page as me. So, what does cybernetics refer to?
So I guess cybernetics, I think the term was coined by Wiener, and specifically, I guess was it one dialogue of Plato. I forget which one, but it's like um, uh, the word coming from a governance, either with respect to governance and regulation. So to like what you would use to like steer a ship, you could govern the ship, or governance like political governance.
Mm-hmm.
Um, and cybernetics, in some ways, is more commonly. I think people will tend to talk about control theory more than cybernetics, but cybernetics would be, I guess, uh, the study of goal-seeking systems that regulate themselves via feedback, different types of feedback. And that would be the
Okay.
essence of it. So, like, you might think of like a heat-seeking missile or a thermostat.
Yeah.
These would be cybernetic systems. They have a target, and then they regulate themselves based on feedback. They regulate their behavior, their state, to achieve those particular goals. And then the cybernetics movement took on different forms, where people started uh, considering more and more things, and tried to model more and more systems in this way. And so then you would start to get like things like second order cybernetics. We are talking about the regulation that's going into um, cyberneticians, or people who are modeling, like governing the modeling process by which they are governed. Uh, it ended up becoming a very like rich intellectual tradition. I'd say that some would say went off the rails. I don't think so necessarily, but the basics of it though would be treating people as goal-seeking systems, governed by different types of feedback relations. Just it, I'd say that would be the essence of it.
Yeah. And that fits right in with the free energy principle as well. Um, so what's really cool about this work is like um, the bringing together of uh, contemporary psychological science, because psychological science is like all the way up here in levels of abstraction, and the free energy principle kind of weaves a thread perhaps between all of them, and yeah, it just kind of fits. So you were talking about how we could kind of take these big five, and then there are two. We could put them into two groups: maintaining stability and plasticity, which kind of fits in with the. This is how the in my mind the thread of the FEP fits in, right? Because we need to maintain, we need to be existing. My body needs to be stable. Like my environment needs to be somewhat stable, so that I am also, capable of surviving across time. And I also like need to learn, like according to this model, like we need to be plastic, which I hate that word, plastic, to develop, like to explain things that can change. Neuroplasticity. When I see plastic, I don't think like changeable, mutable. I think like it's in a shape. Sorry for the
It's
digression,
almost like
but
the opposite of it's the opposite of what's intended.
yeah, I know. Definitely could have been a better word.
No, I'm gonna have to go with plastic for now.
Yeah, yeah. Um, so yeah, I that's why I wanted to just touch on this personality thing just briefly because it's quite it just fits in really really well, and I've never really like thought about it as being able to generalize. And as you were saying, that gives the Big Five model a lot more validity because it can actually be generalizable to cybernetic systems to varying degrees of success or like accuracy. Like we couldn't ascribe um, the same type of psychological traits, of course, to I think the term psychological here is not appropriate because not all cybernetic systems have psychological states, but they behave in certain ways that map onto these psychological states that we uh, have these traits that we have uncovered
What would
through this factor
agreeableness
analysis.
mean for like a an asocial species?
Yeah.
Or conscientiousness. You might uh, I think you tend to only see something like conscientiousness. Um, really some like fairly sophisticated mammals and some birds maybe. I don't know if people have looked for it
Mm,
in birds, but you know, I think people have looked for something like conscientiousness, and I think or they've identified something kind of like it in dogs and maybe chimps. But
okay.
uh, what's the conscientiousness of um, a
An amoeba.
mouse, an amoeba even? So you can go all the way down to that. Or let's say we're going and I think you get kind of an interesting mix when you get to more like certain types of aggregate intelligences, like societies,
Mm,
um, like collective agents. So a society as a whole, um, interestingly, so the stability and plasticity. I'm forgetting her name, but there was this rule makers, rule breakers. Um, I'm frustrated. So there's a there's a fairly brilliant researcher who wrote this book not too long ago, Rule Makers, Rule Breakers, and is characterizing different societies not just by collectivism or individualism, but by basically the tightness or looseness of their norms. And this, I think, maps fairly well onto stability. Is you hold your
mm,
norms very tightly. Everyone has to be with the rules, um, or plasticity you let if it's more loose, you let things slide more, you let things change, you can explore different value structures, and so you'll see those two meta traits, they're applying to really any cybernetic system is going to have this, going to be needing to deal with the stability and plasticity and trade-off between them. They seem like they might be opposed, but they're actually interestingly synergistic. They can be opposed. You can, so there's a trade-off that you can be so stable as to be rigid, or you can be so plastic as to be destabilizing. But in a world where everything's changing and uncertain, if you don't have a good amount of plasticity, if you're not learning, if you're not adjusting, you're going to lose that stability in a hurry. But similarly, if you don't have this base of like, I got my homeostasis, I got like my basic organismic survival, I got this down, these basics. Well, it's going to be hard to have that platform from which you can go explore and try out new things. You're not going to be able to learn very much if you can. You're not going to learn much if you're dead. And so they're actually synergistic, but they're in a dynamic. So Colin calls it a dynamic tension. And um, and within active inference, free energy principle and active inference, you can take this when you're characterizing the goodness of the model in terms of its ability to minimize its expected free energy, you tend to get these two terms that fall out of the equation, these two kind of classes of value that you're optimized for. One would be this intrinsic value of realizing your prior preferences for system world configurations that will tend to be of a um, evolutionarily sensible variety that allow beings like you to exist. But then there's also the intrinsic value of information, and you're looking for sources of like you're looking for ways of like getting uh, opportunities for refining your models. And I think these map pretty well also onto stability and plasticity. And so you're seeing this showing up again and again. And so I mentioned, like, if you get it like the collective level, you'll get some interesting like combinations of things which seem more psychological and not quite psychological of like an individual sense, and that you could think of like a more conscientious society or a more agreeable society.
Sure.
And this could be partially a function of the people that's in it, or it could interestingly be a kind of trade-off, where a more like rigid society could potentially afford more latitude lower down or not. Like
Yeah.
it's
So there might not be a strong correlation between the traits of the society as a whole and its constituent elements as an aggregate. That'd be kind of interesting
yeah,
to look
and the
into. Yeah.
conditions under which you'd expect them to like go together or like be complementary and divergent. I think that's
Mm,
like she gets into that a good amount, and that's a really fascinating piece of work. But to come to stability and plasticity, this balance between them, the dynamic tension, uh, navigating that dynamic, maintaining being the right point of the tension. I tend to think of this in terms of a construct of self-organized criticality, and that um, basically, or the edge of chaos, and that if you basically, uh, so self-organized criticality, with the idea being that um, complex adaptive systems, there seems to be across many of them, or maybe any of them that persist. In order to persist, they need to have this balance of stability and plasticity, of order and chaos. Um, or not chaos, that'd be technically wrong, but of order and disorder. And the way I tend, there's a couple different ways. And so the idea of self-organized criticality is the system will self-organize to get at this, to find this like regime at the edge of chaos where you're not in this point of instability, but you're close enough to it that the way I interpret it is, I guess, in two ways. If you're like in this sort of like close to this phase transition across different regimes, different ways of being, well, that gives you options. That gives you the adaptive capacity of having, I can go in this part of the state space, or this one, or this one. And so having this attractor, having your self-organization move you to this edge of disorder, that's actually a good thing to be at an interregime. That gives you options.
hmm
But then the other way I might think of it is in terms of like the dynamic tension and the balance, in terms of generalized evolution. You want enough plasticity and variability to have different things being tried out, being explored. You want the variation, but then you want enough stability that you can get structure building upon structure. Like an adaptation wouldn't be any good if it just disappeared as soon as it was created. So you need enough stability to have cumulative adaptation or evolution, and enough plasticity to have the variation to work from for replication, variation, selection, the formula for natural selection. And that's the only way that really any system, as far as I can tell, uh, temporarily uh, escapes the maximally probable outcome of just getting dissipating. Like the only way that the second law is circumvented for any length of time seems to be via generalized evolution, um, a free energy person would frame in terms of learning and inference. But that's another connection between them that I see, is that it's fundamental for any complex adaptive system.
Yeah. This really makes me think about and concerned for our governments and our societies, because the governments are kind of our governments are responsible for maintaining social order and taking in information, integrating it, and making decisions based upon what's going on in the world. And they seem to be getting worse at it, or I would perhaps not worse. There's just so much more going on. Like there's a fire hose of novelty and new information that is actually really quite important, and they can't really adapt um, as quickly as is necessary. And there are powers that be, or there are things out there that are stopping that have a great deal of influence that stop or hinder the changes that might actually be that we might need to make. Um, and that's not good. Like we need to, if we don't adapt, if we're too rigid, we die, right? And that's not good. that's not good for the long term future, like the potential beings that could be in the future, the people that are alive now. Like it's really important that we kind of um, upgrade our institutions. Um, and there's like science that's kind of, this is like the science it's pointing at it, right? This is why I'm quite excited about this new age that we're in. I think we're seeing like the coming together of, I guess, values, like the ways things should be. And yeah, I think the way the world is can really inform us about the way the world should be. Like when we're talking about how we should set up our systems, well, it's like, well, at the end of the day, we got to survive, and like the government is directing resources, it's undergoing computations, blah 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 blah, to allocate these resources. So we kind of need to know about the nature of these, of how this actually works, so that we can do this better, so that the number of people that are alive can actually live better lives, so that all sentient beings can, like, whatever value structure we want to chuck in there, it helps to know how systems operate and how they can operate optimally. Um, and then take that information and integrate it into our political models, because, well, hey, that's how these things work. So I think we're at a really interesting time now. And like, if I was, I want governments to, like, just getting complex system scientists and everyone, like, I think complexity science should be taught in school, like stuff, physics, chemistry, and biology. One of them should just be complexity science, because it's just like it's like a whole new way of doing things. It just gets me very excited. And I just
That's the
think it's so
problem.
critical, right?
The
It's so
newness of it.
critical in this moment.
I guess the problem is like the newness of it and the way that some of our intuitions are shaped by basically we're constantly trying to like curtail complexity. We're creating like these um, like highly designed environments and situations for ourselves that like will sometimes be like where there's very clear means ends relationships, and we're trying to get like a really precise causal sequence that we can do to get particular plans. We want to leverage complexity, but like for us in achieving a particular goal, we're oftentimes trying to like constrain it. And so I think people's intuitions are oftentimes like of a complexity minimization rather than a leveraging variety. And so then like what sort of governments will and what sort of relationship do we have between governments and peoples? Well, the governments are going to have to like play to these sensibilities, or it might all just be about like, so the government, what do you want? You want governance, you want to create a certain type of order. But
Mm.
um, this, though, so then you'd have, um,
So, I see it as like not constraint. It's not constraining complexity. I think what we want to do is maximize complexity, but in such a way that it is not surprising, right? It's the surprising factor. So we can have, like, I'm incredibly complex. You're incredibly complex. Like, our society is incredibly complex, but it's only things are only fine. Like, things are fine when nothing surprising happens. When there are no anomalies that could, result in some form of disaster. So we don't want to minimize complexity. We want to maximize it, but just minimize the chances of something bad going wrong. And that's
well,
how I see order.
that's what we really want, is what you're
Yeah.
describing. But I think
Oh yeah,
people
yeah,
don't
yeah.
know that they want. People want this without knowing that that's what they want, and so then
Yeah.
the governments that come in seem to not be what you're describing partially.
Yeah. And I mean, you can definitely see how they're voted in there. Like, people don't want to. Like, it's not very. It's kind of
Like,
scary thinking that, like, oh wow, this, like, the world's a lot crazier than you guys thought, and we're gonna do our best. So there's the person there with humility being like, look, guys, speaking to the country, shit's tough and we don't know what's going on, but we're going to do our best. Versus the guy's like, I know exactly what we need to do. Blah, 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 blah. Vote for me. These people are evil. And, like, we're pretty simple creatures in that respect. And that, I think we kind of gravitate towards people or entities that provide us with that level of, with a sense of certainty. Because, like, one of my biggest takeaways from the past few years is that uncertainty is like the biggest evil, right? Like, it's uncertainty that is what causes the terror. It's what causes the feeling of consternation,
the
um,
biggest opportunity.
and the biggest opportunity, Yeah, yeah. There's a lot of uncertainty today. Yeah.
And so anyone though who like can potentially artificially like go forward with less, help people reduce their uncertainty, giving an overly simple framing. Anyone who has like a clear, tight message, or and potentially really problematically so, um, those ideas will tend to propagate quickest because they're easiest to grok.
Hmm.
They might correspond. They might give people the feeling of uncertainty reduction when really it's it's just sort of like closing your eyes to things.
Yeah.
And then also like if these people with the overly simple frames are forming coalitions, they might form coalitions more quickly. And then there you have it.
Yeah. I think I kind of covered this with like Maxwell Ramstead, in our conversation. We're just talking about like societies needing shared generative models to be able to coexist, and that's one of the problems that we may encounter over the next decade, or which we are already seeing. Different countries having shared models of no, like models that are not completely commensurate with one another, and therefore there could be some clash. Um, and
Very likely will be.
yeah, yeah,
Artists.
yeah. It is. It's a. It's funny. Like 2020 came around. It's like first month, second month of 2020, new decade, and it's like already the teens were just a little warm up guys. Like this is what the next decade's going to be like. Here's the coronavirus. Here's I'm sure there are other things that I'm not mentioning, but it's just like a big wake up call.
I remember that you in that conversation, um, like you were putting forward like a potential candidate uh, over narrative or myth, shared myth, if you will, some sort of based on life and the preconditions for life. Like, could through these complexity frameworks, like through a kind of complexity science, a deep ecological perspective, what are the preconditions for there to be life? Well, we all want to be alive, um, or most of us, and those who don't tend not to be for very long. And so, could this be the point of coordination? Could this be the shared generative model that we enact together? Like we kind of go back to these fundamentals of what do we need to do to live?
Yeah, yeah,
And
yeah. 100%. And it extends beyond like our species, right? Like, because we are dependent upon the biosphere, like we are embedded within this biophysical system that gives rise to us. Like our societies are not separate to. I got into some silly argument on Twitter with this guy who's it's not even worth talking about, but
it's never
just like
happened to me before.
super pro fossil fuel, like we need fossil fuels to promote human flourishing. I'm like, okay, but like what's human flourishing dependent on? Like, is it? Anyway, I'm not gonna go into this, but like the general, I think what can be a unifying like values, like general set of values for our species, it has to be rooted in life, right? Because we are dependent upon the natural systems that provide us with like they do so much work, like economic, like we can't put an economic value on it because how do you put a value on oxygen or like the things that are just critical for the survival of every like all mammals and other things, right? It's a dumb thing to even ask, but unfortunately, we're not making the we're not taking the actions that we really should be taking because we aren't costing these we aren't taking these things, these costs into account appropriately. And at the end of the day, it's like we want to survive, and we are all bound. We're all stuck on this little rock together, and things aren't going too well. I mean, what I actually think is what complexity science and these new ways of exploring the world provide us with is an actual metric for measuring, like I would call it like a material correlate for ethical value. So like complexity or low entropy, right? So our intuition tells us that complex systems seem to be more valuable. Like human beings, we are very very complex, and our intuition says we should promote like human beings are good. We should you know try to ensure that human beings survive. And
They
yes,
can't be.
yeah, but we are like anthropocentric. Our intuitions have evolved over the course of a long period of time, and it was adapted for us to be anthropocentric, or for our intuitions to be anthropocentric. So perhaps we overvalue human life more than we should, or whatever. But
It was very
I
adapted
think,
before the Anthropocene.
yeah, 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 exactly. Um, but so
When you just
we
had
could
this
say
like
that our
giant, never-ending bonanza, and like, oh look, another mammoth. Oh look, Another mammoth. Awesome.
And
Then you're out of mammoths.
out of
And then,
mammoths, and then we had agriculture. We got all crooked teeth. Um,
yeah.
but yeah, we have this underlying intuition that's like, and you could say it's not perfectly calibrated, but it's if it's not perfectly calibrated, then we could say what it's calibrated to, and it looks like it's calibrated to minimizing entropy, like preserving preserving order. Like if we want to just, it's easier to talk about this in terms of order, preserving order, and generating new order, right? And that's preserving order in the social sense, in the biological sense, and also in like the biophysical sense. And we could kind of abstract it. Now we could take that, we could take this notion and abstract it to all these sorts of things, because um, our order is dependent upon all these other systems, right? Like they're inextricably connected, and then I reckon like this could be like a like so it's preservation and generation of that, but these things are probabilistic, right? And obviously your frame counts. Like there's a beetle in cat like there's a beetle that's kind of ravaging Canadian forests or something. So it doing its thing is really good for its species, but from the objective like perspective outside, if it's destroying forests, it's not a very good thing, because the net result is a reduction, is an increase in entropy, destruction of complexity. And I reckon that this can kind of really fit into a I think this could be like a way that we can kind of measure, even if it just really approximately, um, good actions and bad actions. Like what should we be doing? Okay, well, the Amazonian rainforest is being destroyed, and I don't know how we'd measure the like entropy or complexity of something like this. I don't know if we actually have really. I'm no expert in complexity science or thermodynamics or anything, so I don't know how we'd measure these things. But even if we were to just do it from like a very 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 back of the napkin type thing, um, I reckon it could give us some indication of what we should be doing with regards to certain things. Um, anyway, that was just a big ramble. Um,
It's There actually could be some measures, and some of them related to criticality, which could be used as generalized measures of the health of any cybernetic system. And so, like, um, there's some wrinkles there. And so, like, for instance, like, how do you know if a system is actually at this like edge of chaos regime, or like is exhibiting self-organized criticality? There's a couple things you can look for. Um, so sometimes people talk about power law distributions, or seeing like across scales, although that's contested because you can get power laws from non-critical systems. Or people might look for things like critical slowing down, like when you make a perturbation to the system, does it like have a certain uh, is the response does it seem to like resist perturbation, or have some interesting response to it? You can look at things like fractal dimension. There's different like ways of characterizing uh, critical systems, but one thing that could be somewhat thorny is that, interestingly, um, very complex adaptive systems, they're not necessarily critically organized in every single part of them. You might have some systems which have more stability, some which have more flexibility, and if you're looking at different metrics within an overall like um, organism or ecosystem, you might only want like some processes. You might want some to be like ultra stable, like we're not ultra stable. You might want some to be very stable, and you might want some to be very flexible, and that you can get this synergy across them. And so you would need to have that kind of um, to know which complexity measures to apply. You would actually need probably a good causal model of what each of the subcomponents of the system are doing, and where they should be with respect to like different amounts of stability and plasticity, and what types of dynamics they ought to exhibit. I don't
mm,
know if that makes sense.
yeah, no, that makes sense. I'm just thinking about it in the context of our civilization. Like, you want energy, your source of energy to be very stable, right? You don't want too much experimentation to be going around with the energy grid, because energy is central to you know our lives, and for us living our technologically advanced lives. But you might want lots of plasticity around, or experimentation around the generation of new science. Um, but I don't know
Yeah,
how you would model those as like bounded systems that kind of interact.
I don't either. Mm, Am I losing it? Ah, um, although some of these measures might be, I don't know, some of these measures, but so for instance, like, so some of these principles could apply in a kind of global way, even though you might look for different stability, plasticity, balances to be there at different points. There still is a sense in which I think you probably should expect the overall complex adaptive system to be critically organized, even if there are subcomponents which aren't. And so, like, mm, and so you might get some reads that are just surprisingly powerful and useful. Like, for instance, like heart rate variability. That's like a complexity measure for us, which actually, so you don't just want to completely steady heart. You want it to be adjusting continuously with, like, on the inhale and the exhale to get you in this right balance. You want to be adjusting not just to the inhale and the exhale, but to what you're anticipating. So, like, as you're anticipating, I'm about to go into a mode where I better, like, get up and get it. Now you're adjusting it, or now things are fine. Well, then you bring it down, and so this, you can actually quantify this one thing, like how variable are your cardiac dynamics, and but this ends up giving you a really good read on overall health, overall well-being. Just this applying this complexity measure, just this, in a way, it's analogous to actually kind or this one source of energy in life.
Mm.
So, like, and even like, it could even be the case, like, for, like, even like an electrical system, you need, like, you don't, you want it to be ultra stability, you want it to be meta stability in order to work, in order to be, to adapt to changes. It's like, things go down here, you want some of this capacity. So you want the stability, but it might be of a metastable or ultra stable variety that already has within it. And so these complexity measures might work even there. It's like complexity and variability, that's the real stability. Like,
Mm.
or
Yeah,
that
it's ironic, like to be stable across time, you need to not be stable. You need to adapt. It's like and it's the process, right? It comes down to there is this process that we need to adhere to. Um, it's like the meta process that enables us to survive, and it's maybe we've just been refining it, but it's been there since day one, and it's worn different clothes across time. But I think it's going to be true from our level of complexity all the way up to when we become spacefaring species, and maybe capable of you know using physics that we haven't even discovered. Like this will be still the case that we need to walk this tightrope between um, the unknown and the known, uh, the like chaos and order, or that as you said, chaos isn't actually the right way to
order and
refer to that,
disorder.
but order and disorder. Yeah, we need to work. We need to walk that tightrope to maximize potential, but yeah, that's basically what it's. Like maximize potential adaptation without uh, that resulting in chaos or disorder, destruction, death, all that.
And I guess the question would be, like, how do you know, not the question, but a question, an important question would be, like, how do you know that the balance is right? And so, like, if you're, uh, it'll vary. Like, if you're, so, like, if you're an organism, there's a sense actually in which, like, your heart rate variability, for instance, you actually have this read on, are you in a zone of uh, proximal development, or at the edge of the adjacent possible? Are you at the right place where it's neither too much nor too little? Like,
Mm.
so sometimes you do want, like, you know, you want that the heart to reduce its complexity because you're just going to go into, like, a do and die mode. But then, like, if it's always that way, well,
Yeah.
you're not at that point. And so it
It's
would
like
be
good
both.
enough is good enough, right? It's that thing. Good enough is good enough because there's diminishing marginal utility. Like you could be it could be perfectly attuned to your needs moment to moment, but the marginal like the utility you derive from that, and like the amount of energy you have to expend processing and adapting at all times isn't worth it. It just needs to be good enough to do the job well enough.
Good enough, and as good as you can. But if you,
But
it's
given
but
resource
yeah,
constraints.
given resource constraints, um, and within the range of what you're seeking, actually, not going beyond what you're capable of actually pursuing. And so it seems like you need a metacognitive so like there's some things which would give you a kind of minimal metacognition of, are you balancing, are you in basically the zone where you ought to be, um, as a complex adaptive system. And there might be some just like heuristic or reads, a kind of implicit metacognition. So it's like, I feel bad, I feel good. That's like I feel like I have this handled or not. But then you would want on top of that other metacognitive varieties of, well, what is happening and what am I doing? You actually want different kinds of consciousness to actually be able to model yourself explicitly, and am I on a trajectory? And so that would be another thing that you know consciousness was a major advent in evolution. That was
Mm.
not just using feedback loops with these indicators, but actually predicting trajectories for the system within a world that you're able to model, and then using this to chart your way. Not just like not just like not. I guess there's a sense in which it's always gradient ascent on feeling good, or gradient descent on trying not to feel bad, but doing that not just with respect to like the immediate engagement with the world, but with respect to what you're imagining might happen next. And that seems like something that can be difficult to happen. It's difficult for individuals, and it's potentially even more difficult for collectives.
Yeah, yeah, yeah. Well, I mean, we can apprehend, we are conscious, so we kind of have like a bit of an idea about what's going on here. But I don't think our, like, the USA isn't awake and aware as an entity. At least I
It
don't
seemed
think
that
so.
way.
I think this is a good way to. I kind of took us on I derailed us a bit. I kind of wanted to get to some of this stuff a bit later on. So I want to really talk about consciousness and
Hmm.
integrated world modeling. Like the integrated world, integrated.
Integrated world
I
modeling theory,
That's the one. That's the one. So
IWMT for short.
IWMT. All right. So I guess a good place to begin might be just to hear your take on what do you think consciousness actually is. Um, like, how do we think of consciousness generally, and whether or not those characterizations are correct, or whether or not they could be better characterized or chopped up into little pieces. I don't know. And then we can talk about IWMT.
Sure.
Yeah,
Um,
awesome.
so I guess consciousness. It's a word, and Minsky would say it's a suitcase word. It's a word that's been pushed too far and given so many meanings as to almost be meaningless. I don't think that's quite true. I think we're okay with the way we use language. It's not perfect, but it's nothing is. And but I do like the idea of factorizing consciousness a bit into the different senses of what we might mean. And so I like onion images, and so I kind of think of consciousness like an onion with like different layers of complexity being built up. Or I can think of it like or growing out of it, um, uh, or like a tree that's growing up an onion, let's say. And so like you might have like this core of just an intelligent modeling system, and then at some point around this ability to be intelligent and model and perceive and act, the ability to have a modeling where you might then say that there is something that it is like to be that modeling process, where you might say that there is subjectivity, a point of view, or and I think people would call this a phenomenal consciousness. The emergence of a first person ontology from what otherwise you would describe from a third person perspective as a system, but now this is a system where there's something from the inside that it's like. Um, some people would say and so where you put that in like this process of evolution and emergence, there's debate, and I have a take on that. But then like in the ways we use the word consciousness, you then could add more complexity. So now you could talk about conscious access. So the ability to be aware of your experience, to manipulate your experiences in mind and report on them and tell them to others. And so knowledge of experience. That's potentially a different use of the word consciousness and a meaningful one. And then you might have with that, maybe little bit out, or like maybe a little bit in, like self-consciousness. And self-consciousness of different forms, where not what you're aware of is yourself as a being in the world in a particular type of way, with a certain temporal and spatial extent. You might get all the way to the level of, an autobiographical selfhood, that you're telling a story about yourself through time, and this is a mode of consciousness. And people sometimes use the word in that way, like your consciousness of yourself as a being. And so with integrated world modeling theory, I was focusing on phenomenal consciousness. I was focusing on what are the preconditions for there to be something that it is like to be a system. And so what I did was I basically cross-referenced as many of the different theories as I could that would address phenomenal consciousness, and address the brain, the trains, the processes by which brain or any complex system might give rise to consciousness, and then cross-reference them. I focus mostly on integrated information theory and global neural workspace theory, and look for the points of overlap and difference. But and I put all this kind of within the overarching perspective of the free energy principle and active inference, as this overarching framework for basically allowing for synthesis and adjudication among competing claims of different theories. So with integrated world modeling theory, the claim is that phenomenal consciousness is what it is like to be an generative modeling process where you are generating a model of where you're generating likely experiences given a model of the world. And I argue that there are certain types of coherence properties that you would need for there to be anything that could appear whatsoever. And so I took a page from Kant, and so he argued for any kind of coherent judgment whatsoever, you needed these synthetic a priori categories, or these complex synthetic but before experience intuitions that let you structure further experience, and lets you make sense of things. They're preconditions for judgment. And so then the idea is, well, these might. So then I was wondering, are these preconditions for any world to appear whatsoever to any being? So things with respect to coherence with respect to space, time, and cause. And so space, I'm understanding, is like locality, or some things are closer together and further apart than others. Time is in things move about in this space in different proportional ways. So some things are moving more quickly, more slowly, and we will sometimes peg this, and we'll create timelines. But this way of describing the way things move in space, time, um, with relative proportion, and causation in terms of there's regularities that you can track. And the idea is that unless you have coherence with respect to the ability to place things relative to things and account for their changes and the regularities in those changes, you're not going to get a world in there won't be a world. For there to be a world to appear, I want things relative to things with particular properties. Otherwise, I'm not sure what kind of world it is. I'm not sure what it would mean to say, like, what it is like to be a system from the inside. You say, like, what it feels like. The idea would be basically, I think when we talk about consciousness, at least for ourselves, we're saying this world of experience, our experienced world, this bringing forth of a world that we experience from a subjective point of view. And so the idea is that you need these properties. And so then I looked at the neural systems that might help to give rise to these, that might afford these capacities for these different kinds of coherence. And so what ended up being and then thinking, are these the physical and computational substrates of consciousness? And so one among parts of the brain that, or neural systems that could be useful, and which I believe are the ones that give rise to our phenomenal experience, it would be particularly the back of the brain, the posterior part, as these hierarchies of patterns off of your different modalities. So off the back of your head, it would be this hierarchy of vision, which then would split into different things. Would split into, you have your what stream as it goes down low, and your where stream as it goes up. Really, it's more of like a how affordance stream. But the point is, you'll have like from your sound, you have a hierarchy there, and where these hierarchies all come together and can exchange information. And now you have access, or now all these different forms of information can be brought together with synergy. Well, that's going to be helpful. But then for creating like, for figuring out what's in the world. But the other part that would be essential is for any of these modalities, you need the reference frame. You need to actually say, from what's being experienced, from whether what's being sensed, what is the relationship of this sensing being with relation to the world that's you need this as part of accounting for what the sensations are. Like, as you for instance, like right now, most of the motion on your sensors is actually generated from your own action, from your own motion as your eyes move around. But it's also, to account for what you're seeing, you have to know what's my pose relative to the world. And so you're going to want to have neural systems that have access to, where was my head pointed? and and so it turns out that some of these like, structures, that when you actually uh, disrupt them, they will cause altered states of consciousness and potentially even loss of consciousness. They have access to all this information. You'll have access to all the different modalities. Where's where's my body pose? But also, so there's a structure called the posterior cingulate, which couples closely with this other structure called the precuneus in the back of the brain, and this precuneus, it's associated with actually mental imagery. It's really we're talking about aphantasia earlier, and so the vividness of your mental imagery tends to correlate there. And then if you lesion that area, you will lose those abilities, and you can get um, you don't usually get like tight lesions there because like it's tucked in like right in the midline, but you will lose different forms of consciousness. Um, but this structure that's talking closely to the posterior cingulate, it's it receives stretch receptor information from the neck. It receives information from the vestibular apparatus, so it knows like the yaw, pitch, and roll of your head. And so now it has all of your modalities organized by your pose. Now I think you have what you need to construct a model of your sensory engagement and produce an experience world from a point of view. Uh, there's further things from like it seems like for this modeling process, you might need a system of a sufficient size that um, you can have um, that 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 basically the subsystems which are creating an overall model of the organism and its relationships to the world, that these models can evolve and update without constantly being disturbed by the immediate engagement with the senses. So you might need something of a big enough size that it's not just this continuous flow of information and messages, but that you're actually generating estimates of what's going on. And so in global neural workspace theory, they'll talk about these ignition events, or Dennett calls it fame in the brain, where you're basically selecting a winning interpretation of what's going on when you get enough activity building up that you get this kind of explosive percolation, get these big synchronous complexes forming, and that somehow, and so there's an interpretation of this as a Bayesian model selection, or a selection, an iterative selection of what's going on. And so for your phenomenal consciousness, for us, I would argue that it's likely generated at alpha frequencies about 8 to 12 times a second. And this would be it would use this belief hierarchy over your senses and fill this and generate likely sense data given everything you've experienced. And that for me, this iterative estimates of where you are chained in time, that's the stream of consciousness, 8 to 12 times a second, the inversion of a generative model over your sensorium, given a history of experience where the whole thing is entailing a model of the world that's capable of keeping track of things coherently with respect to space, time, and cause. That's like the nutshell of. I think you need that. Or rather, you don't need that, but you need, like, I think that's how we do it, and I think you need a system that can do something analogous to that for there
Yeah.
to be a world that appears to it.
Yeah. Okay. So we need to. I'm just going to see if how well I understand this. So we need to. We've. This is hard. But you did a good job of explaining it. It's just there's like so many moving parts and things that kind of fit in, right? But I just that fame in the brain thing. So I might just start from there. We have like these competing probabilistic notions of what's going on in the world, and the sense data contributes to how strong those probabilities are, and the ones that really scream out our conscious awareness selects as like that's the most accurate, or that's our best guess as to what's going on in the
Sense
world,
data
right?
plus priors,
Sense data plus price. So
plus
we've got
plus your
like
expectations, the
yeah,
intersection
so
of the
we
two. Yeah.
okay, so we've got all these like little bets, like our brains generating like all these little um like counterfactuals for a better term, like what could be explaining what's going on, and then the one that has the most data we select, and then that becomes our new prior. Okay, that's
Yeah, almost like a prediction market of sorts, like with like winner
yeah,
take
yeah,
all
yeah.
dynamics, and it's always wrong. But because you just generate it, because you're always generating a new one, like 8 to 12 times a second, it's good enough that you can get by. And so the purpose of it would have a couple purposes. But it would be basically it would allow you to both basically to more skillfully navigate action perception cycles. So you'd want it you would want these updates, these estimates to form quickly enough that they're capable of being informed by your ongoing engagement with the world, that can be informed by perception, and that they can inform things and shape action. And so there has to be a certain, in terms of like closing these functional cycles of acting and perceiving, you have to generate these estimates quickly enough. The system has to be capable of doing this so that you actually can make sense of things, that it's
Mm-hmm.
actually capable of being meaningfully updating and then updating. If the relations, if the temporal relations are off, like let's say it's like a very slow extended process. It's like, is a forest conscious? Maybe not, because the action perception cycles won't be tight enough. Too many things will enter the mix by the time you get these, like, by the time whatever information is cascading through it, it wouldn't be enough to meaningfully be informed by, because too many things would be happening, or bring form to the engagement with the world. And so there has to be a certain alignment and for the rate at which different attractors are formed within and without. And so I think that
Mm-hmm.
places a limit. And so I don't think forests are conscious. I don't think entire nations are conscious. I think embodied organisms with fast neurons, with small world network architectures where everything could talk to everything else pretty quickly with a few steps, that could do it. You might be able to do it
And
in other
that needs to be
systems.
integrated, right? It needs to be like that talking needs to be integrated into some model, or I don't know what the right terminology here would
Yeah,
be, but of what's going on moment to moment.
and have to be integrated quickly enough.
Yeah.
Uh, And so, um, and that's actually part of like with integrated information theory. So I was taking these uh, so they're starting from the basics of what they think any conscious experience is like, uh, and then they're saying, based on these axioms of what characterizes all experience, what are the mechanisms that could realize it, and they create this way of handling certain types of complex systems that feed back on themselves, and they characterize this the irreducible self-cause effect power of systems, and as their integrated information, and then they say the degree to which you have this is the degree to which you have consciousness. I don't think that's the case. I think it's rather the degree to which you have this is the degree to which you can engage in kinds of complex property processing that could give rise to consciousness, but we got to ground it. We have to give it a body. And so the
Yeah.
idea is like taking the workspace dynamics described by things like Dehaene and global neural workspace theory, these ignition events, these synchronous complexes, and then treating those as complexes of integrated information. And then you look for the biggest one, and it just so happens to be the one that would correspond to this joint um, estimate over your entire sensorium in the back of the brain. That's where it will tend to be. With the front of the brain tending to do this more like forward-looking modeling, but it doesn't appear to be the this, but it doesn't appear to be the thing that's generating the stream of experience itself. That seems to be always in the back.
Yeah. So if we were to try to like say one thing was more conscious than another, Like what sort of variables would we like look at measuring, or would it be like the the gigabytes, the number of gigabytes that are running from moment to moment in this integrated model? Or like I think there might be multiple things that kind of feed into here. It'd be like the updating cycle, like the number of times per second this is happening, the amount of data that's in there. Um, I don't really know. How would we even begin to measure this if we could?
So it's it's interesting actually. Like global neural workspace theory doesn't have like an objective way of addressing that question. I wouldn't say, but integrated information theory does. In terms of the different estimates of the amount of irreducible complexity. And so to actually do the calculations for any system of any appreciable size as described by the theory, to do the proper calculations, that's just a non-starter. You can really only do it like analytically for a system. I think of last I checked, it was uh, uh, 11 or 12 complex nodes, or like eight or nine, like, or eight or nine complex nodes, or like 12 like logic gates with like on or off. And then after that, it just explodes and the calculations wouldn't happen. Um, it would take, you're running into like, age of the universe stuff. But there's estimates, and so one of them is this zap and zip method, or the perturbational complexity index, where what they'll do is they'll, for instance, for a person that you want to know if they're like, let's say, locked, like in a locked-in state, or it's like a deep coma without consciousness, or let's say you're dealing with someone who's either like dreaming or like in deep sleep without dreams. Put electrocap on their head, you take a transcranial magnetic stimulator, you pulse their brain with activity, and then you look at the complexity of the waveform. You look at, and you specifically look at um, how big is the zip file. Like if you actually try to zip the data set, and the more irreducible, the harder that is, the bigger the zip file of the evoked thing. That's one read on it, and this is actually fairly powerful for estimating differences between, let's say, dreaming and dreamless sleep. Um, it, it's
So
it's
if you're
it seems to work.
dreaming, are you the zip file is larger than if you weren't dreaming?
Yeah. So in slow wave sleep, you get these big pulses and everything sort of, or these big swaps, these big slow synchronous complexes, and then um,
I didn't get this word complex. Like in this,
uh,
like what is a what is a complex here?
an ensemble of coordinating elements of varying degrees of softness and firmness that are coupling in a coordinated enough fashion that you you say that they are some kind of unit, and so a
Yeah.
complex.
Okay, so if like they've got a Mexican wave in a stadium and the people kind of waving in some, like it doesn't need to be going around, but they've got a big group of people kind of waving their arms in certain synchrony. It's not perfect. Would you call that a complex?
You could use the term differently. So you could either say like the traveling wave is itself,
Yeah.
like as that's like a moving complex. But let's say like it loops back around and creates
Hmm.
like a clear harmonic pattern, where like you can say like it creates like shapes, like standing waves.
Hmm.
Those could be complexes too.
Okay.
Um, but the and so I think you can get at. I don't know though if I would say that's necessarily. I think it's likely to be, but it's not necessarily. I think you can use that to say um, what is the vividness of someone's conscious experience, like what's the level of intensity of it. But if you're talking about um, consciousness in the sense of knowledge, and having uh, like a conscious system that has like a good model, that'll be harder. And I don't know if there's like a clear complexity measure. Like I'm actually like beginning, so I'm starting to move in the direction of trying to go from, okay, phenomenal consciousness, all right, but now what do we mean by, what are the means of access consciousness? Like what is accessed? How is it accessed? Um, what is self-consciousness? What is metacognition? That actually, in some ways, I think is a lot harder than the hard problem. I actually think the hard problem it's kind of a statement that will get me in trouble, I'm sure, but I I think part of what made it so hard was we were impatient about waiting for the right bridging principles that you could have something that would seem plausible to you, like something like probabilistic modeling as a framework. And academics and scholars, they just didn't talk about the body. They if you talk about consciousness in the abstract, outside of any given sensory experience, why should anyone? It should just seem like this complete impenetrable mystery if you lost track of the fact of the core of experience itself, what it feels like. If you don't talk about the feel, if you made that taboo as not serious, not being academic or intellectual enough, then we got that. And then if you add on top of it, well, we don't even have like a bridging principle across levels of analysis. But I think we're actually at a place now um, where we can say, yeah, I mean, it's going to depend on like your sensibilities, I think. But I think the hard problem is close to being solved. I think the real challenge, what's much harder, is going to be these other forms of consciousness. That's going to be that's the real difficulty.
Hmm. Love to see like a taxonomy of consciousnesses, just like a picture of all the little types and how they fit together. I think.
Like like an example of like self consciousness and metacognition. So something I'm wondering about is as a way of modeling it. So okay, you um, so from the models I'm working with, consciousness is always from a first person point of view. It's always a view from somewhere. It's always there's a reference frame from some observer. But when you imagine yourself and model yourself and become conscious of yourself and use this for complex forms of metacognition, what was I doing? Where was I? Who am I in this respect? That you have to somehow objectify the self. You create like a third person representation. And so part of what I'm wondering is, for instance, um, how is this generated in what system? So, for instance, let's say you start imagining yourself enacting some sort of sequence. Like you imagine yourself doing something, like I'm going to go make tea, and you're picturing yourself making tea. But when this happens, associatively, there will be linkages to things you've seen of other people doing these sorts of things. We're constantly like we actually kind of come from a very early age, we mirror with other people. We're doing this mapping from others to ourselves. And so, in theory, you can create this sort of like, depending on like degree of like how where you are on an aphantasia spectrum, you can you can access these objectified representations of agents doing similar things, and then as you're simulating different yourself in different situations, you then have something that's um, you then now have act so that you can then potentially bring online via these associative linkages images of agents doing similar things. And this counterfactual you can then make it do different things by enacting different things, different mental acts, or you could like do things like fictively like foveating across. You can like inspect the thing and like take different points of view on the objectified representation of you. And so then there might be this like back and forth between like different neural systems being more or less dominant as you're like moving back and forth between like taking either the point of view from within or from without. And this seems like the kind of thing we're going to need for like metacognition and self-consciousness. I think it's going to be this sort of kind of crazy bootstrapping story of crazy. It's if you don't have it, you're crazy. But it's going to be something of that nature. And that it's like when we're talking about something like model selection over your sensorium given experience, there might be more like kind of well-defined processes that you could like meaningfully describe in terms of neural systems. But here it's like when you're getting to things like self-consciousness, you can talk about the relevant neural systems, but the actual like to diagram it out in terms of the entities and their interrelations, it's like you can't point to anywhere in particular. It's this like really like hairball unfolding of strange loops.
Hmm.
That seems a lot harder to me. I think the hard problem is cake compared to that.
It's the first problem on the test.
Yeah. First or second?
Yeah. So I want to talk about free will in this context.
Sure.
Um, and that term has a lot of baggage. And you said yourself you had an existential crisis when you were younger, and I've kind of had one as well. But I'm just like, well, it feels like I have it. I don't think I have it. I don't even know what I mean by myself. And the more I've been learning, I'm like, we have all these individual. We might be constituted of more lower resolution personalities that are competing. Like these probabilistic models that you were talking about, the prediction markets. Maybe they're like little personalities. Like what actually constitutes the self, and um, if I am, even if there was one unitary self, that self is still like somehow, if that unitary self is somehow in here in my brain or in my body, how can that act in such a way that is divorced from the material in which it makes it up? That kind of leads to action, and then we can call that some freedom of will. Like, so I know I've just dumped some nonsense there, but what's your take, and how does it fit in with your understanding of consciousness in the brain and all this fun stuff? Get the mate. Get the mate.
Uh,
He was just drinking a caffeinated beverage to prepare for this journey.
the triple shot's still going pretty strong. This is just some water.
Oh,
But
okay, okay.
um, the maybe a little too strong. The I think there's a similar issue with like suitcase words, right? And like we're gonna want to be more precise. Like, what do we want from free will? What are the varieties of free will that we want, and to what degree do we have each of them in which circumstances? And so, like for instance, uh, Dennett, it's basically he thinks like the most important one is agency. Can you have goals and can you pursue your goals? And but other people they want you can go to things like I want to be an uncaused cause. It's not clear anyone wants that, but the idea of having spontaneity, of having optionality, having your options opened. Some people value unpredictability with respect to what's about to happen next. And these can be sometimes synergistic, sometimes at odds. So, for instance, Dennett argued that uh, determinism is the friend of free will, and that to the degree that we're not dealing with deterministic chaos and with sensitive initial conditions, but the degree to which the world has predictable structure, that's better for planning. And so that'll be an easier situation for wanting what you do and doing what you want, and adopting this agentic stance with respect to yourself. Um, but if you're, let's say, in a rival context where there's other agents who you're like competing against or cooperating with, there might be an advantage to having unpredictability about you in terms of your ability to not have your goals thwarted by others who would be competing with you. And so being somewhat illegible even to yourself could be an adaptive thing to like not even know what you're going to do. And so you might get some of that, for instance, through things like actually sensitivity to initial conditions. Like Jun Tani has, like he tends to think of like the frontal lobes as giving you some of this free will just because of the nature of recurrent networks to be so nonlinear by the way they feed back on themselves. The idea is like through this like these complex bifurcating dynamics that no one can predict in advance, this could be a source of spontaneity. I've been tending to focus more on um, the micromechanics of goal-oriented behavior and agency and like achieving goals with feedback, and can you um, based on the information you're having uh, get what you want from the world, and how do you do it on the uh, both on the like very abstract terms, like what does it mean to pursue a goal, but also what are the algorithms you deploy and what are the neural systems. And so that I, I would view that as basically, for me at least, the most important kind of free will, the ability to achieve particular goals in the world. And so, in terms of causation, so then what people would, and what I was worried about is, well, there's not a neuron in my head that knows or cares about me, and I have no idea what they're doing. I have no idea which ion channels are opening or closing. I have no idea about the individual particles, and they're just doing what they're doing. Like they are like the charge, that's just obeying Coulomb's little, that's just the electrochemical stuff, that's just Maxwell's equations. That's the kinetics, that's its own thing. And that's not me. And so the resolution, for me at least, also in a way came from Dennett, from his book Freedom Evolves, in terms of viewing basically, uh, and later Sean Carroll wrote really, I think, beautifully on this in the big picture. But it's so Dennett would viewed eliminative eliminative materialism and determinism as negating free will as actually a category error, where once you go to that level, so once I start talking about neurons, once I start talking about particles, well, why should I expect to be able to talk about these higher level patterns when they're not defined on that level? It's not within the scope of that ontology. And so then Sean Carroll will talk about like with I think calls it romantic realism, where it's like everything is like, so you're having this sort of thing that is, and maybe you could just like hypothetically there's like a set of like master equations that would describe like what the God's eye view would be of like Laplace's demon who knows all things and sees them evolve. But that's not our world. As soon as we start using language, we're coarse graining. And so actually we are renormalizing. We're throwing away the internal detail and only paying attention to the higher level attractor structure, and even and we're only paying attention to those. And so there's a sense in which uh, determinism wouldn't be an enemy because um, the causation on that level would not influence the causation on the level which you would do if you took the agentic stance or elsewhere. The idea is like um, when you're doing causal analyses, there's you define the system in a certain way, and then once you define the level and you just define the ontology, define the kinds, and you're looking at the relations among them, you can't switch like mid explanation. You have to pick. So if we're talking particles, that's causal for that system if we're just talking particles. But then if we're now talking about a higher level set of causes and we're coarse graining over it, that's another causal account. And you don't switch. And so there's a sense in which uh, eliminative views on free will from determinism, they're actually meaningless in a way, and that they violate the rules of certain language games and also our formal handlings of causation. They violate the assumptions, like Pearlian causation, where you set up a graphical model, you do interventions, you cut things, you move things, you see what changed the probability of what. You got to pick. What am I trying to explain? And so I think for all of it, uh, causation. Part of the problem is I think we overly reify causation. So people like Bertrand Russell said, like he says it's like the monarchy, like it outlived its time. I don't think we should do that. I think causation is great as long as we understand what it is, which is a way of like predicting and explaining things. It's not like just floating out there in the ether, handed down from like the philosopher king. It's a way of making sense. And so then once you do that, you're like, okay, wait. Now the game of causal inference, the game of doing causal modeling, well, there's certain moves that are allowed and not allowed. And it seems that eliminative accounts of free will from determinism, that is not allowed in any of the causal games I know of. Um, there might be some, but it's not. That's just not a. When we get precise about cause, when we try to do it formally, that's just not a thing people do.
Hmm.
I don't know if
And
that
if we
makes
want to
sense.
talk, yeah, no, that made sense to me. A part of me just thinks like we still got the problem of like who am I? Like in like like if we have these I don't mean that in like the incredibly deeply philosophical sense. Like yeah, it's more like am I? Do I have a unit? Is there a unitary self, or am I like a collection of sub personalities, or um like is there this one entity that is somehow causally affecting the actions that this body takes? Like if I'm not, if I'm somewhat separate from my body, is there this thing, this one unitary thing that can affect change such that I can I can pursue my goals? Or is it like an amalgam of different, we were talking about before, like interacting subsystems that could be considered, that amalgamation can be considered this unitary self. You kind of see what I'm getting at?
Yeah. I mean, so like, there's a sense in which, like, for instance, you could say like you are a game theoretic equilibrium. Equilibrium. You are a set of game theoretic equilibria over these subagents in the society of your mind, and when they are capable of when the game structure is such that particular solutions happen with a certain degree of regularity over and consistency, that you can create a thread through them, or you get coordination. You're like, well, that's me. I'm the victor's history and the revisionist victor's history over like this pandemonium within. I think that's not wrong.
I think that's how
But I think there's
if you're at a party, like, oh, so who are you? Well, this is fun.
and
And
then you
then
join
they
the
just like, all right, I'm going this way.
you join Cosmic Clippy and Cthulhu, and you stare off into the void with menace, yeah, and laugh maniacally. Um, that's what I do. At least. That's how I am at parties. That actually is how I am at parties. But the um, I think when the mechanism design over the games is structured according to narrative, then and we're back to Dennett again with the self as center of narrative gravity. Like um, that when you get an attracting manifold for all these coordinating and competing agents, where what the dominating coalitions will be is structured by a narrative, which then feeds back into the narrative process, which then structures the neuronal activity selection. Um, then you could, I think, if that narrative has a consistency over time, and it actually does have this property of serving as a source of entraining power, then I think you could be said to have a self, and your self would be that center of narrative gravity. The There's a sense also, like we were saying earlier, with like the multiple realizability of things, and like the way like words can provide like you have these sensitivities and initial conditions. There's all these things that be different, but then like the word lets you course grain over all of that like mess. There's a sense in which like our goals and values and meanings in these narratives serve that function. Like all sorts of like fluctuations can happen, all sorts of uh, you know non-linear chaotic dynamics can unfold. But if at the right part of the system you have uh, representations of these goals, and that they're positioned in the right way, that they can entrain, uh, then I'd say you have like an autonomous self to the degree that's the case, and it's by degrees. It's
Mhm.
yeah, and so the yeah, I guess the one more thing I guess about this is with respect to consciousness is um, and so being aware of these narratives, that's going to be helpful. But there's also, I think, um, both for those being capable of um, meaningfully connecting with your experience, but also there's a sense in which phenomenal consciousness, so not just not conscious access, but phenomenal consciousness itself. Um, I agree with IIT, with integrated information theory, that actually consciousness is the dominant cause in the whole system. It's that this maximally uh, self-generating complex. But like if you're really good at um, having this harness complexity, you're going to be good at driving other things. You're going to be adaptive. You can create coherent flows and adaptive flows. And so the dynamic core of, or which would be centered around like the brain's rich club, it might be maybe 50% of your overall brain metabolism. And so there's a sense in which your consciousness is a maximal cause in that way, like however you slice it. Like, and from it's like the dominant prediction, but it's also like energetically, it's probably the most expensive thing your brain does, and it's paying its weight somehow. I think it's paying its weight because it lets you surf uncertainty. It lets you stay on top of these action perception cycles, and and that's how it pays its weight. And also needs to have that weight to do it, to actually meaningfully drive coordinated activity. And so having uh, a large scale, the ability to generate topologically central with respect to the overall network, large scale, high power complexes that, if they have the right information, could entail consciousness. Um, these then can be used to entrain or enslave the overall system in different directions. And I think this is a sense in which you are a cause. This is a sense in which you have free will, in which your consciousness is potentially, under some circumstances, a maximal cause of what happens. Now it depends, though, which part of consciousness we're talking about. But that would be the idea that phenomenal consciousness is actually the strongest informational and energetic object in the mind. And I actually think that when we're finally done with the taboo and we finally have a little more clarity, we're going to be like, oh God, what were we doing all these years? Like treating, like we're basically, people treat consciousness like as just like, oh, that's just philosophical. It's actually the most real thing in the mind in some ways.
It's the only real thing that we kind of. It's the realest thing because everything else that we perceive is an appearance in consciousness, and it's just a hallucination. Like consciousness is the realest thing for each of us.
I forget who said that, or who said this, but it's like, consciousness isn't just the elephant in the room; it is the room. Yeah.
Exactly. Um, so having covered consciousness and free will, I think we can move on to the very fascinating topic on what actually can just completely transform our conscious experience: psychedelics.
Sure.
So, um, what the hell? What happens in the brain when you take a tab of acid, or if you eat some mushrooms, or smoke DMT, or like I'm sure like they're all different substances, so they may have similarities and differences. That they'll have similarities and differences, but what are the similarities? Like, what do we know is going on when we have these when we go on these journeys?
So, before I go, that quick correction. So the 50% figure, that's actually the rich club of the brain, like the highly connected set of nodes. That would be the most connected, the most signaling elements. Consciousness, I would argue, will tend to center along these, but I think the exact like energetic costs of the particular signaling that's giving rise to your experience, uh, that's like that's going to be more complicated. That's going to depend on like what it specifically is in the scope of what's being synchronized in what ways. It's not. I don't know if I'd say it's 50%. It would be like some. But the idea though is I still would say that it is. It can be the dominant attractor, and it's not just a mere epiphenomenon that's just like along for the ride. But altered states of consciousness. Um, so I guess the standard model within predictive processing would be the Rebus model by Carhart Harris and Carl Friston. And they argue that you have relaxed beliefs under psychedelics. And so, viewing the brain and mind as this giant belief hierarchy, the idea would be that where you're passing your prediction errors upwards and your prediction errors upwards towards deeper parts of the hierarchy or higher, and you're passing your predictions downwards, and where the predictions are your experience, that with psychedelics, specifically the classic variety of serotonergic ones, 5H that target the 5-HT2A system. That what
So
these will do is they will
what like for example, because which ones target those things?
mushrooms, LSD, DMT, uh, uh, different cacti, uh, San Pedro, mescaline. Uh,
Okay.
that these would, I think, uh, that these would by exciting the 5-HT2A by stimulating the 5-HT2A receptors, which tend to be concentrated in the deeper portions of the generative model, the deeper portions of the brain, the more removed parts, that you excite them so much that they fall out of sync with each other, and that this causes a relaxing of your belief landscape, and that you now have qualitatively, you don't have these strong prior assumptions anymore. And so now you're able to actually see more of what's in the world and experience more, and this would be associated with a kind of like um, more intense experience with more rich details as you remove and potentially unusual connections, things like synesthetic phenomenology, um, or seeing things that would be different than your expectation as an hallucination, when you remove this strong dominance from the top down, specifically from things like the default mode network. I don't think that is necessarily incorrect. I think that really does get at a lot of it. I've been proposing, though, that we need to augment the rebus model with strengthened beliefs as well. And so specifically, if you look at this class of receptors, the 5-HT2A, it's not just located on these deep pyramidal neurons that will tend to loop with the thalamus and form these big synchronous ensembles, which can stitch together big models and pass beliefs over distance. So it'll excite those and potentially throw them out of sync, such that you actually end up paradoxically weakening the predictions. That's possible. They're located there, but they're also located at the upper levels. So cortex is like, it's got these 6 layers. So it's this big dinner napkin that's crumpled into your head. And then if you look at the cross section of the napkin material under a microscope, there's 6 layers, roughly 6 layers. And so the deep pyramidal neurons would be the lower parts of the napkin, and then the superficial ones would be the upper parts of the napkin. And the predictions will tend to be coming from the deeper parts of the napkin that's crumpled up. By deeper, I don't mean along the whole range of that, but like within the cross section. That's what I mean by deep pyramidal neurons. And then superficial would be the parts that are facing the outside. And those are where your prediction errors are passed upwards. And so you'll see that these 5-HT2A receptors are also located at the inhibitory interneurons of the surface of the napkin. And so what I would argue is that the rebus model conflates the emergent properties and phenomenology of the intense full-blown psychedelic experience with the receptor level mechanism. I actually think at the level of the cortical microcircuitry, it's the opposite of what they say by and large, although it might happen at the extreme doses, but that if you're at like a low to a moderate dose, or maybe most like physiological ranges as you would get stimulation under natural conditions, that it would actually tend to be a increasing the ability of these large synchronous ensembles to form through the excitation. There would be a point where if you excite too much, they could fall out of sync, but that it's not clear that this would happen from any degree of exciting the units that talk to each other over distance. It's not clear that they would fall out of sync by increasing the ease with which they fire. It would only be at the extremes. But further, because you're inhibiting the ascending stream of prediction errors, or you potentially you would, again, you might get different emergent properties with different levels, but most straightforwardly, if you're increasing the gain on the things that are inhibiting this, if you're increasing the inhibition of the thing that would communicate the prediction errors, it seems like not only might you have more intense phenomenology, stronger predictions, depending on what level of hierarchy we're talking about, but they're also shielded from disconfirming evidence. And so I think this would be consistent with things like hallucinations that appear with sensory deprivation, like a flotation tank, or like Charles Bonnet syndrome, where people like will lose like their they'll start to go blind from like their eyes, but then they'll start getting intense visual hallucinations, or from their ears. You lose hearing, but then you start hallucinating things because you're not getting this contradiction of your expectations, and so it ends up being your waking dream becomes less tethered to the world. It becomes more like a dream proper, more like a decoupled dream. And so I believe psychedelics, the mechanisms are complicated, but I believe that the classic psychedelics work largely by increasing the strengths of your priors, and shield of your perceptual priors, and shielding these from deconfirming evidence. And these also might be your priors at the level of every stage of the hierarchy, some of which where you have higher level attractors over your perceptual states, higher level things that might correspond more to things like dynamics of like inner speech and habitual frames. Those could get strengthened or weakened depending on the amount of stimulation if you're telling the story at the level of just the activation. However, let's say now you've just made things different. Things are now, you're starting to see things differently than they were there. Radically different, like there are aliens talking to you. that's going to that itself will cause relaxation. That's a different world. Like if you
Wait.
experience
You said talking to aliens will cause relaxation?
that might cause you to say, I don't know what's up. You
If I
might
was
then
talking to aliens, I don't think I'd be relaxed. Like normally, maybe in like the DMT zone, maybe it's a bit different. But like, if I was talking to aliens, you'd be like, "Holy shit, bitch me."
it's exactly like pinch me, or I don't know what's real anymore. I don't know. Like you might have people call it like an ontological crisis. You might think
Mm,
the world is radically different, and in a lot of ways, um, that would be um, for a lot of people that's the journey, and that's actually the benefit is it's helping you to see things different than they could be otherwise. And so this could happen from like a receptor mechanism like they talk about in rebus, or it could happen just because you're pushed into a different like area of mind space, and then you experience things that are radically different, and this causes you to see things differently. I guess I would add one more thing, which is in terms of like psychedelic as like mind manifesting. So under this like strengthened beliefs idea, if you're lowering the barriers to entry into consciousness for different percepts, different beliefs, if things come up more easily, in theory, this could cause you to see things that you might normally avoid. And this could potentially cause you to certain patterns of convenient direction and misdirection of your attention, like the things we hide from ourselves. You might see them. And so, like, let's say, like, you're struggling with addiction. Well, you might then say, like, you might then like see the concept. So through so one part of addiction is just experiential avoidance. So the things you're avoiding, that might just come up. There it is. You gotta deal with that. Another part would be um, there might be consequences to what you're doing that you don't like, and maybe you don't like looking at those either. There's sometimes you like looking in the mirror, and sometimes you avoid the mirror. And here's the mirror, and that could cause therapeutic change in that way. So it could be either, or let's say you just schematize some aspect of your life as being unimportant. You got habituated to it. You stopped paying attention to things. You might like realize, wait a second. Um, the people in my life, wait, I'm so glad they're there. We have all the, like we do this, they do this for me. Wait, I could do this. They appreciate me in this way. It's like these things you just take for granted, they just come up again. I think that would, and so I think you could tell the story either in terms of relaxation of beliefs or strengthening of beliefs. But I think and I think you'll need both. And the idea is like you have this, um, it's a different world of expectation, but with an elevated consciousness level that makes things more vivid. And at some levels, if we're talking about things like hallucinations or potentially delusions, or potentially insights, it would be this increasing the gain on your priors or your predictions. I think would correspond to the um, the anomalous inference, the seeing what's not there. You're seeing
hmm
what's not there because your priors are too strong. Um, and that would be a hallucination. That would be a miscalibration.
hmm
That's
Yeah, I
my
think
take at the moment.
when I said relaxation, I think I misheard you because you said relaxation of your prior beliefs. I just thought you meant if you see aliens, you'd be more relaxed. I'm like, I think that's. I think I misinterpreted you there.
That could happen too. I mean, like uh, like for some people, the thing they might be avoiding or just what comes up might be some kind of like hellscape, right? And
hmm
then you might have no choice but to have a kind of relaxation, of a kind of surrender. You just, okay, I'm dying now. You just, what are you going to do? And then after
Yeah,
you're okay with that, maybe you could be like, if you can face that, what else can you face? Maybe you then adopt a stance of greater acceptance of your experience and more flexibility and awareness from that.
yeah. This makes me think. So, like, I've dabbled in the past, and I've always experienced like mental fatigue afterwards. Like it's like having spent when you spend a lot of time doing hard mental work, you feel a type of fatigue that's different to physical exercise. it's different to the fatigue that you feel from physical exercise, but you're still drained. I'd love to know if brain metabolism goes up by 20 or 50% during these experiences, because that's how it definitely feels like that. It feels like there's just a hell of a lot more going on.
I mean, in theory, like these, I don't know what would contribute to it the most, but in theory, so part of the fatigue could be just like if you're having an intense experience and you're doing different things, uh, dri- you're driving your body harder than you would normally. That could be a good amount of it. But in terms of like, in theory, if you are elevating the gain on the signaling units which mediate your conscious experience, and you're basically overclocking them, that could be part of it too. That could be there could be a metabolic drain on the systems, which you then uh, through a kind of implicit metacognition reads as fatigue, saying, "Okay, we drove this system pretty hard. Let's ease up." Uh,
Hmm.
we tend to like. It seems like we have mechanisms where we're like our felt sense of fatigue oftentimes is surprisingly different than our actual energy levels. But what we're doing is we're kind of like predictively saying, okay, wait, how tired ought I to be given the circumstances of what maybe I need to do next? And it's like in theory, like you could like move, like you could keep pushing your body far farther than you do, but
Just
you
like
get a
we're doing
fatigue.
now, just like we're doing now.
Just like that. Yeah,
We're not talking about the weather.
I'm feeling it a bit. And
And yeah, yeah. And listeners, I hope that you are hanging in there as well.
so it's possible that that's part of what's driving it. It's just like uh, turbocharging turbocharging consciousness, but it's and I've seen different things from different studies in terms of like there does seem to be an overall increase. So under a Rebus model, not necessarily focusing on like the circuitry, the idea would be that like so you if you remove the highest level predictions, well then the rest of the system. So usually these predictions are of a suppressive variety. They're suppressing. They're they're explaining away the lower dynamics. They're keeping prediction errors from going higher. But if you remove these predictions, well then you can get more prediction error, more activity, and maybe that's the metabolism. And that probably actually um, might be closer to the point um, in that it seems like the majority of the energy and like the reason you do predictive coding, like let's say you're like looking at MRI and you look at like where the blob lights up, where the blood flow happens. I believe that tends to be most strongly driven by prediction error. That tends to be more this surface activity that's not successfully predicted, and you're getting these like flare up events of cascading messages upwards. That seems to be the most energetic thing. And part of the reason you do predictive coding is not just so that you can be quicker and stay on top of things and be a good model. That's the main reason. But part of it is if you are primarily suppressing this activity and only communicating where you got things wrong, you end up coming out ahead energetically. So that's why they like predictive coding. Initially developed for televisions and telecommunication. With let's say you're having this frame updated like 23 or 24 times a second, and what you're depicting isn't changing very quickly relative to the refresh rate. You come way out ahead in terms of the number of bits you have to communicate just by communicating the differences from frame to frame. And so if all you're doing is communicating where you got things wrong, and if the events of the engagement of the world are are evolving more slowly relative to the neuronal signaling, you might come out ahead in a similar way. You pass the fewest messages, the fewest action potentials, the least
Mhm.
energy. But if you remove these highest level predictions by whatever means, that could, in theory, both give more fodder for the richness of your experience, um, but that the price you paid is all that ATP.
Yeah, yeah. Okay. Um, so this reminds me of a conversation. I kind of want to talk a little bit about meditation, but before we get into that, I'll talk about it in this context. I'm just curious to hear your thoughts. Um, so I used to have an EEG headband that I would meditate, and it basically measures your brain waves in real time. Supposedly, it's reasonably accurate enough for it to be used in certain research in certain experiments at universities
The
around the world.
Muse, is that the one?
Muse, yeah, I had the Muse, yeah.
I've heard good
Um,
things.
yeah, and so I had that for a while, and I would use it most days. And it takes into account um, what is it, alpha, beta, gamma, theta waves, and it kind of condenses those down into. You can either get the raw data, or it interprets it and says you're in a calm state of mind, or you're in an active state of mind, or whatever, and it would give you auditory feedback depending on how active your mind was. And so you'd sit there and meditate, and if you were zen, you'd hear like birds chirping and like the leaves slowly rustling. And if your mind wandered, and I found that this was quite accurate, like it seemed to map onto my experience of a good meditation session pretty well. So if your attention wanders, the soundscape would start to get quite um, agitated. The trees would be blowing, and the wind would be blowing, and the birds would stop chirping. So it was this there's just real time feedback on what the state of your brain was like. So I was meditating with this for a while, and then I had a DMT experience. Um, and the next day after the experience, I meditated with the headband, and my data. So you see your graph. It'd just be like up like high was active, low was Zen, and prior to the experience, I was quite active. But then afterwards, for about the space of a week, I was just super calm and collected and zen. Like I could just slip into the zone, for lack of a better term, far more easily. And I remember in the experience that I had this. So I kind of, for those of you who aren't familiar with DMT, you can kind of break through. You kind of go to like a different space, a different place. At least that's how it feels. Um, and I felt that I was focusing in on my thoughts and that they were distracting me from like the experience that I was having around me. So I experienced this very profound sensation of separation from like self and thought. And then I was like, all right, dude, stop thinking. You just gotta, uh, you know, experience what the hell's going on. Put your thoughts aside. And I think it was that separation from self and thought that resulted in the really profound changes in the EEG measurements from my meditation session the following day. And
What
that
were
didn't persist.
what were the readings the following day? How were they different?
Way lower. So if this is the graph, like if instead of it being up around here in the high levels, it was like close to like
So
the lowest.
much less gamma, less beta.
I'm not sure what like so it interprets it and then gives it into one line. So I didn't know what the raw data said and I didn't know how to interpret it. But I would love to do this as a citizen science experiment. We just get citizen scientists around the world with Muse headbands, and then or a whole bunch of people, and then we choose to engage in these in psychedelics. We use the headband for 60 days before, and then have a psychedelic experience, and then take it and then meditate for 60 days after. See what happens.
I would be very interested in that, and I'd also be interested in seeing like the difference. So it might not be straightforwardly related to like what you observe during the DMT session might be different than what you observe afterwards, or it might be similar. But like, so I think in a recent study they're showing decreased posterior alpha and increased uh, frontal theta. And it would be interesting if that was what you saw,
Well, theta
or
is the dream. Theta is like the dream. Like that's what's correlated with dreams, right? And
it,
alpha's consciousness,
imagination,
imagination.
imagination, but also in a way executive functions. So theta would be the ability of like the hippocampal system with the frontal lobes to loop with each other and basically guide the whole system through different orchestrate guiding the system to
Yeah.
different areas as like you're navigating and
Well,
as you're
that mapped onto
navigating.
my
Yes.
experience because like I'm like pretty chaotic and I struggle to get myself under control. But I could just slip into that zone way faster than I could normally. Um, so
So like, I wonder, like, is it like afterwards, so it's like during the experience you had this experience of intense meaning, and from the meaning, greater ability to be conscious of things and focus and direct things, or not, but like depends on how much DMT, I imagine. But the
Yeah.
um or
Yeah, I see that experience of separation from self and thought. I think that might have been the catalyst. So perhaps that might have been what really made the like generated the effect, but I'm not too sure.
yeah, I'm wondering, like, you can think of it like afterwards, and it might not be that, but like, are you self actualized, or are you free from self? Are you in like this sort of like blessed surrender, or are you like, or is it just you, or are you just less in conflict with yourself, and like, so in the experience, like, did you feel kind of did you feel more like you were just letting things be, or did you feel like you were
Mm-hmm.
directing things?
No, letting things be. So I felt like by thinking, I had binoculars, and my binoculars were focusing on the thoughts, but there was just this incredible amount of activity going around me, and I was just focusing on my little tiny thoughts, and I'm like, I'm missing this. I'm missing the show. Like, shut up, stop talking, enjoy the experience, which is quite interesting as well. Like this, like there's all this stuff appearing in my awareness that I wasn't generating. At least that's what it was novel. Like I didn't feel like I was generating. Um, like it was, yeah. It's like sometimes when I've been stoned, like um, my subcon. It's like I've got my eyes closed and I've just got a projector screen, and my subconscious is just throwing stuff at it, and I'm just watching what hell my brain throws up. And sometimes it's like hilarious stuff. Sometimes it'll make me chuckle, which is funny to think that you can make yourself laugh. Like in humor, there's surprise, right? You need to like you know what's coming. You don't really laugh at it. Um. So yeah. Anyway.
But you can actually be surprised by your own experience. You can actually, instead of trying to direct your experience, it's
I was
going with the
watching the
flow of it.
TV of my brain. Like, I was just like literally like a spectator to the fireworks in my head. It doesn't happen all the time with cannabis. It's just I think it depends on the strain or whatever. But it was yeah, pretty interesting. Like I don't like any idea that I have isn't really mine. It's just like I don't take any ownership of the ideas that I have, because it's just like I've taken in information. My brain is the consequence of like lots of evolution, and it's filled with thoughts and ideas that I didn't come up with. And there's just this underlying machinery that's going that just spits shit out. And the conscious apprehender is like, oh, that looks pretty good. I'll put that out into the world. Thanks, like subconscious. I don't take any responsibility for that stuff at all, except for being able to guide my attention towards things that I find interesting, but I don't know why I'm interested in them, and I'm not very good at guiding my attention. So I don't take much responsibility for anything in this regard.
Since there does come a stage, it's like there's stages of development where you want to direct the flow, like the child, you want to give the child agency and will, and make it control things, and become a particular type of thing in the world, and get particular things happen, and learn particular things. But it's an interdependent process throughout, and also those very control efforts, that very goal seeking, can undermine itself and becomes overly rigid. And at some points you can just, I guess, less let go. I heard, like, in like, this is true, but uh, like in cultures we have Confucianism and Taoism. It would be like Confucianism would be like there's a long period of like entraining yourself to ritual in the group, and then at a certain point you just like you've earned the privilege of, once you've like grokked ritual enough, that you can just like, now you can like enjoy the Tao. Then you like go into the woods and like become a sage, and it sounds pretty good. I'd like to have both things.
Yeah. Um. So we've got we're at about 3 hours. How are you feeling? What time is
I'm
it?
okay. It is 10:30.
10:30. Okay. Um, well, I
Probably turn
reckon
into a
we
pumpkin at 11. Like,
yeah. I reckon we kind of think about bringing this to a wrap soon, and maybe we can have a follow-up episode sometime in the future. Um, but I guess there's a lot that I think we've covered. We've covered a lot. I think there's a lot that we haven't covered, and I've kind of taken us on these silly tangents. But
they weren't silly.
where, yeah, yeah. Sometimes I just get a little bit excited. Um, so, is there anything that we haven't covered that you really want to bring up, or that like if the talking point that you really want to hit on, or go over again, or clarify? Um, I know we got some questions on Twitter that I do not know enough to really be able to understand and ask you them because I don't understand what they're asking me so clearly because I'm just not too familiar with this whole space.
So I had one question. What does synchrony do in the brain? I think synchrony promotes coherent communication among neurons that allows them to create ensembles which are greater than some of their parts and figure out things that they couldn't do on their own. And so you have to align the neurons and their activity in time so that their activity can actually sum rather than decay. And so through this maelstrom of possible signaling, you can get coherent patterns through orchestrating different rhythms. Some of these rhythms, call them, I call these different ensembles self-organizing harmonic modes, and some of them might entail consciousness if they're over the right set subnetworks that have access to the right types of information and the right circumstances. But each rhythm will do something different within these predictive processing stories and within these stories of the brain as a complex hybrid architecture. Uh, there was this question about um, some recent beef between radical and activists and the free energy principle. And
Yeah,
is
did
it
we hit
in
on that?
fact,
Did we hit on that?
we
Like I
touched
feel
about
like
auto
we
police.
touched on it. Yeah,
So I suggested that it is that free energy principle you can call it like highly compatible with autopoiesis, Bayesian autopoiesis. But Evan Thompson, who worked with Francisco Varela or extensively, says no, this is not doing justice to it, and um, that's a whole
and
issue.
the Ramstead reply came in, which I didn't really understand, but someone called it, Maxwell Ramstead's reply, and they said, "Here's the Ramstead reply." I thought it was hilarious because, you know, he comes out with these great threads in
It,
response to
it,
the stuff on the FEP.
one of some of the best threads, and one of the things that's actually I thought was interesting about that critique, and this is an ongoing issue, and Max is working on it, is like, so when you're not within this non-equilibrium steady state condition, when things aren't so things that are changing and have not achieved, they're not steady. Um, when the Markov blanket is constantly changing, you can't identify a clear boundary. How do you model these systems? And there is and this is not resolved in the free energy principle. I don't think there is a clear way of describing it yet. And in some ways, it kind of corresponds to kind of like the traveling wave versus standing wave issue of like within like the stadium. It's like on some time scales you can say there is a harmonic, there's a standing wave, but like if you zoom in, it's actually full of traveling waves. Is there a right or wrong answer? Well, it depends on what process you're talking about with relation to what other process with which it's coupling. But there's like an interesting thing. It's actually a Buddhist idea of, or from Nagarjuna, of like uh, emptiness is form and form is emptiness, or like it's only because things are do not have this clear everlasting essence, only because they're constantly in flux, constantly interdependent, changing, that they can actually be as they are at all. So there's a sense in which the system is constantly changing. It's never the same system of river of experience twice. And so, like, what's the system? Is it a new system? It depends. But this that issue, it's interesting that they're getting at what Evan's talking about there with I think that might be part of the intuition that like autopoiesis is saying like these systems that are answering Schrodinger's question, the only way they do it is actually by being both system and non-system almost at the same time. Like they have this openness, this indeterminacy is the thing that gives them what determinacy they happen to have, what definitive is. That's I have to look at that more closely, but that's my understanding there. And then I think there's another question on what is life? Um,
Yeah.
another
So
word.
actually, I was going to ask you, like, because what are
Yeah.
these questions? What is life like? If we take this free energy perspective, or this, like this thermodynamic perspective, this thermodynamic or complex adaptive systems perspective, where it needs to be, persisting um, across time, combating the entropic tide incessantly, constantly, um,
How?
so maintaining form. But how? Yeah. So I mean, you can have like self-replicating. Like I think that the first that what might have started the journey was self-replicating molecules, right? And they somehow led to, like, through some bootstrapping thing, led to the earliest life forms. And I was just thinking through this idea, like you could consider that, like perhaps the first. I have no idea here, but I wanted to ask you this. I actually wrote this down. It's like perhaps it's not the molecules, but like it's the first collection of these molecules that has some form of internal model, or that is the model. Like I wouldn't really call a self-replicating molecules as a model of the environment, but perhaps the earliest life forms were the first ones to embody a model of the environment in some way.
I actually, this might not quite be what you're saying, but I actually have been thinking. I think along similar lines to that. I actually am increasingly suspecting that the thing that differentiates, like, well, the life, where we might want to reserve the word for it, and from something that seems lifelike. So like any um like any dissipative system, like it's like a whirlpool, things are flowing through it, yet it's maintaining its form. It's impressive, and like a candle flame, it's lifelike in a way, and it's like, huh, that's interesting what it's doing. It's showing a certain um, type of adaptiveness to not. There are these like rectifying processes happening that within the flux is keeping the thing. And but this, I think, separation might be between the whole system being in its dynamics, the modeling process, but then reserving some, as the system gets big enough and complex enough, a subsystem which can not be immediately engaged in the exchange, but can give you a kind of additional modeling on top of it and intelligence on top of it. So, like for a cell, it could be it could be something like a somewhat shielded metabolic cycle, or maybe like a pattern of like gene expression to some degree. Like the separation of like DNA from proteins itself could be part of it. But this creating a separation. I mean, there's a sense in which I actually think the hard problem of consciousness and hard problem of life might heavily overlap, in that what moves us to saying that we have a model and are not just a model, and that we have not just like a model that can be intelligent in a particular kind of way and give you a a modeling of the overall system by virtue of being shielded. It can now, in its dynamics, estimate the whole thing. Um, that with for life itself, you might need something similar in terms of like the complexity of metabolic cycles accumulating some logic, some implicit logic, some emergent functional module, a dynamic module, constant chain, but that itself allows for a greater degree of hierarchical control and hierarchical modeling, and that might be one of the key things, is creating
Hmm.
this inner loop thing capable
Yeah.
of doing modeling of the overall system. And so I'm wondering if that is required both for consciousness and for life. And so there might be a sense in which the answer to Schrodinger's question and the solution to the hard problem, there's a sense in which they might be one and the same. Even
Yeah.
though, like, I'm not saying that everything that lives is conscious, but there might be a sense in which the form of it and what's needed informationally might be very similar.
Hmm. Because if you, like in the case of life, if you get rid of the model, then at the smallest level, it's just like mechanistic, right? Like something happens, and then the the proto-organism responds in a way by virtue of that, like the nature of that mechanistic interaction. And then these things, like there's no representation, there's no like processing. It's just kind of, it just happens. Like cause, like there's a very linear relationship between cause and effect. There's no like, I guess I don't want to keep saying the same words, but integration or processing or anything
Yeah,
extra. It's
but
just
like the system encounters this, and then it just deterministically, or it's always deterministically by
yeah,
my view, but it then responds like through this immediate coupling. But
yeah,
in theory, you could get like a kind of like optionality and a flexibility afforded by having like something removed that can adjudicate and select among the different modes that you could enter, rather than just this like simple fast loops. Instead, you can get by having a hierarchy of mechanisms where some of these mechanisms can have their own kind of uh, temporarily decoupled attractor dynamics, that these could give you modeling of the overall system of different degrees of detail, but that this can give you much greater adaptability and switching among appropriate modes. And so I'm wondering if that's the thing. Like it's not just uh, the system reconstituting a system being able to hold its form, but a system that holds its form via a particular kind of modeling, a particular kind of at least like two-tier, like a particular type of hierarchical modeling. And if that's necessary for life, and that's also the thing that moves us from radical inactivism to this marriage of inactivism and cognitivism, where within this, one of these submodels, if it's got access to the right information, could give rise to consciousness.
yeah,
That would be beautiful, wouldn't it? If the solution like had the same form, the hard problem of life,
yeah, yeah. It'd be amazing. That'd be really, really cool.
could be the case.
Two birds with one stone. So if people want to find out, you know, if they want to follow your work online, if they want to check out what you're up to, if they want to read some of your papers, where should people? Where would you direct them?
Oh, I guess ResearchGate, Google Scholars got the papers. Um, uh, I use Facebook as a science blog by and large, and same thing with Twitter. So
Yep. So you're happy if I just link those in the show notes?
yeah,
Yep. Um, all right. Well, I think this has been a fun, winding conversation. Glad that we finally got to do it. Um,
me too.
any requests from the audience? Anything you'd like to mention or say before we wrap up?
There's an audience.
Well, there will be.
Um, let's see. No, just I really enjoyed this, and let's you and me keep the conversation going, and anyone else who's interested, contact me.
Sounds good. All right, Adam. Thank you.
Thank you.